Okay, so thanks for joining. Today I'm going to talk about how to start your Web3 project compliantly, or how to launch a token and not go to jail. Now, I'm going to talk about a lot of kind of ideas, some hard fact rules that you can go and implement today or tomorrow. But the first thing I do want to mention is that none of what I'm going to say is legal or financial advice, nor and you should hire your own professionals, nor is it any type of legal service, and the views I'm going to present are my own and not the ones of Collider Ventures. Great, so let's start. A little bit about myself. So I come from a background of working with startups. Today I work as an associate GC at Collider Ventures. What we do, a lot of what I do is working on investments and also working with our portfolio companies on various legal crypto-related issues, and also we work with regulators, specifically in Israel, on policy issues. Now, if you're tuning in, it's because you want to start your Web3 journey and do so with minimal to zero kind of legal or regulatory risk. So the way to do that is, go work for Apple or Google. This comes to say that this is an uncharted path, and a lot of what we're doing is new, and we're talking about mitigating risk and managing risk and not eliminating it completely. So keep that in mind when you start your journey. So I want to kind of begin the conversation with kind of a timeline of crypto, kind of a brief history of crypto. So we have obviously Bitcoin in 2009, Ethereum 2015. Then we have the 2017, 2018 ICO boom and bust, followed by kind of a bear market, and then DeFi summer in 2020, and coming into kind of blow-ups that we've seen culminating with the FTX winter. And the reason I'm pointing out these events, I'm obviously losing a lot of color in the middle, is just to kind of draw from them some major issues that present legal, kind of legal new waters, if you want to call it, and things that we have to deal with. And this is not totally new to crypto. You can see it in areas such as cybersecurity. Each time there's a leak or a hack, there's regulation coming. So yeah, brace yourself. And the asterisk is because we have MiCA that's coming in, and there are some regulations that apply, but this is going to be kind of what you should be used to. There's going to be changes coming in. There's going to be regulation that comes in response to other to events. So let's jump right in to kind of the heart of the conversation. And I want to start by discussing about decentralization. And this will be very useful when we move on with the presentation into kind of the middle of it and the end. This is how I want to start and why it matters. So decentralization makes technological infrastructure a public good, and especially when it works interoperably with other tech stacks and protocols. It's also censorship resistant. So we talked a little bit about Apple and Google. We all know about the force and the control that they have. So decentralization in that aspect makes the tech stack that we discussed, no one can block you from it. It allows for new incentive mechanisms and financial ecosystems that are innate to crypto and crypto systems. And it allows for new ways of participation, okay? Again, that are native and unique to crypto. So this is kind of one of the most important merits of decentralization that I would like to focus on. And here are some frameworks or kind of mental models for builders listening when you think about decentralization. So we obviously have decentralization on the tech stack, right? We have blockchain computing, which is open source and free for all. Economic decentralization, meaning with token economy, value can accrue to multiple stakeholders and not necessarily to a shareholder or some manager at the top. And legal decentralization, which is kind of what you guys know is on-chain voting, but in general, the permissionless decision-making and the open participation for all. So these are kind of the frameworks of decentralization. And I want to expand, obviously, on the last point, because this is a legal discussion. So the legal framework for decentralization. Generally, financial regulation around the world comes to tackle the problem of information asymmetry. Meaning, you have this agent principle problem where one person or a group of people control or has access to information that is disconnected from the people entrusting them with, be it funds, be it investment in their company. Okay, so we can think about a bank, we can think about an IPO. These are things that you probably know from just general and daily knowledge. And the way to mitigate that risk and tackle that is by disclosures, right? So if a company goes to do an IPO, it presents these stacks of papers. These are disclosures. This is just information about the company that comes to level the playing field and make financial markets more efficient and more open and fair. Now, diving a little bit into the Howe test that most people in crypto know very well, but it's the American test for what makes an investment contract a security. So this comes to, basically this touches the managerial efforts of other, the last and most important test of the Howe test, which basically comes to say that if any person has managerial powers over a certain asset or underlying a certain asset, then we want to tackle that with regulation that is solved through disclosures. And this is kind of the single most important issue when we talk about crypto, in the sense of securities, but also in the sense of custody of assets and many other topics. And I argue that this is the most important topic. So you bore with my presentation and you still want to go ahead and start your project. That's great. So now we're going to kind of tackle or see some more practical advice and do's and don'ts. And I'm going to focus in or hone in on token launch just because that is maybe the most special and hard event for a crypto project's lifecycle. And it's obviously very specific to crypto. So we're going to start to talk about that. So you want to launch a token. The first question is why, right? Why have a token? Your life is great. The SEC doesn't want to go after you or your loved ones. Why do it? So you want to introduce a token because you want to have decentralized on-chain governance in your protocol. You want to use a token as a unique incentive mechanism. Now, you can do that with USDC, you can do it with Bitcoin or Ether, but there's something that just opens a new world of opportunities when you do it with your native token, right? It's programmable, it's linked to the success of your project, etc. And safety. A token can enhance safety on the decentralization part, meaning talking about a 51% attack, talking about buying tokens to circumvent the will of the project. The financial price of the token will make it very expensive and very hard for that person. So we want to launch a token to kind of touch and enhance these points. But when? So as you can see, and as opposed to what we saw in kind of 2017, 2018, launching a token should come at the end of kind of a process of decentralization. So you start your project as a centralized entity, kind of a startup, and you start off kind of traditionally, as you will say, you try to find a product or build a product, find product market fit, marketing, business development, and then you slowly move into the realms of Web3, build a community, find different third parties to build and participate through grants or what have you. And at the end, you do hand over control over the protocol to the DAO with a token, and you do it gradually through kind of a well-thought-out plan. So when you ask when, the question is, A, it depends, obviously, because I am a lawyer, but also it has to come at the end of a roadmap. And and you basically want to strive for sufficient decentralization, which we're going to talk in a moment. So now we'll move on to talk about some kind of more practical advice that you can implement tomorrow. So the first is about token sales. When you're starting out, you want to sell your tokens only to accredited investors, meaning I see projects where very early on they want to go to an ICO or an IEO or an IDO. Do not do that until you're decentralized, and it will just put you right in the Howe test. And the Howe test is an example of many other tests around the world, so it doesn't really matter where you're operating from. You might have this problem regardless. So you want to sell your tokens to accredited investors, which means some equity and net worth requirements, or selling to professional investors, which in today's day and age is less of an issue with more professional angels and VCs around there. Kind of the industry has evolved and matured. And I do want to say that with MiCA coming into effect, it will happen in a year, we will see developments regarding token launches. We don't really know how the playbook will look, how different member states will enforce it, but there should be development there. So in a year from now, this presentation might look a bit different. So this is an evolving space. Next big advice is try to avoid exposure to the US, specifically on the part of securities laws. So we know that Gary Gensler does it like crypto and everything is a security. In general, try to limit selling tokens to US people. Even once you're decentralized and you want to do kind of this big token sale, limit US people. Secondary markets have a lot of benefits, but they might bring regulatory scrutiny. So you should think with yourself whether limiting it, blocking it on the tech level for some period of time brings more good than harm, and maybe pursue that. If you can at all not have much footprint in the US, that's obviously a good idea. And on the same token is also limiting access to users. Again, more on the UI front. If this is something that your project can handle, you should definitely think about that. Next up is communications in general. So if generally there's someone here who wants to develop a protocol and is hyping it as an investment opportunity, just stop doing that, okay? This is just a really, really bad idea. And this is true externally, so don't go on Twitter, but also internally. You should really pay attention to how you communicate. And these things will be scrutinized in potential future enforcement or litigation. Eventually, people will have access to those communications, and it will look bad. And also, it just shouldn't be kind of only an investment scheme. Again, the token should facilitate decentralization. Any communication, be it external or internal, indicating a core team in control, making decision in kind of a centralized way, is a red flag, and it shows that you didn't achieve or didn't reach the sufficient amount of decentralization that you should be. And this is true regardless of decentralization. Obviously, the third point, if there is a core team, it's not really decentralized, and any of kind of the investment hype that you might be building will look bad regardless of your decentralization level, and it's, again, not what you should be focused on. Okay, as we talked about a few slides, in a previous slide, you want to achieve sufficient decentralization. And the way to do it is through this process that we discussed that is basically titled progressive decentralization, meaning you start off as a centralized entity, and slowly over time, you have a roadmap to achieve decentralization, okay? And this doesn't happen overnight. This happens kind of a well-thought-out plan. And the token should be kind of the final note or the final act in a well-thought plan for decentralization. And the utility doesn't really matter. This is something that is kind of new from 3 or 4 years ago. We used to think this, if the token has a utility, it's not a security, it's not an investment contract. That's not really the case anymore. And what you can see on the screen is that this is a very recent kind of court, a dismissal of a suit against Uniswap. They were attacked in court, and basically the judge released them from any obligation because of their decentralized nature. So utility did not play a part. It wasn't part of the discussion. It was all about decentralization. So maybe the point, the most easy advice to implement is to wait and plan it thoroughly. You have to realize that by launching a token, you create a lot of focus on price and a lot of extra noise that maybe is not the right thing for your project. And also makes it hard to pivot, makes it hard to go back and change things. It's kind of an only forward mindset. So we talked about token launches. Now I'm going to touch a little bit about other legal matters. And basically, we know that crypto is kind of this new beast in the world. It creates a lot of new legal issues, privacy, banking, taxes. And these things sometimes are not that specific to crypto, and they're ever changing. So perhaps the biggest advice I can give you is you need a lawyer. You need someone who understands what your project is doing exactly, and when you're selling crypto, and can be available and with you on an ongoing basis. But I do want to pinpoint one thing, which is KYC and AML. And if you're building some sort of a DeFi protocol, and you can implement tracking, monitoring of suspicious behaviors, wallets that have interacted with be it Tornado Cash or other malicious addresses, and do something about it, meaning blocking them or whatever it is that you can do, it will greatly improve your position in case of future enforcement. So all of the banking legislation talks about, it's a lot about effort, a lot about risk managing, and not kind of a 0 or 1. So if you show effort, it will put you in a much better spot. Okay, so this is going to be my last topic that I'm about to discuss, and we've covered kind of some advice, some things you can do, but obviously the most important topic that I would like for you to kind of go home with is the importance of decentralization, and how decentralization puts you in another world when it comes to legal compliance, okay? Not because you don't have to comply with the law, it's because a lot of laws and regulation will be less relevant to a decentralized protocol. That's at least the argument brought by a lot of the crypto law community, and what we are working, people around the world, working with regulators to kind of transmit to them this information, that a centralized and a decentralized entity are not the same when it comes to managing assets or issuing whatever it is that you're selling. So how to decentralize, how to think about decentralization. So on the tech stack, you want to be interoperable. So obviously, we're talking about protocols that runs on the blockchain. There's this element embedded, but you want to have your tech stack built such that people can join, tap in, build on top, use it as much as possible. This will help for the decentralization narrative. You want to promote transparency. So obviously, we have on-chain voting, and everything on-chain is transparent, but you want to have this transparency off-chain. It can be your communication channels, documents, anything that discusses technological development. The more you can bring things to the surface, will just improve your decentralization level. And the role of the token should come to promote decentralization. So we covered that in a previous slide, but you want to use the token as a decentralization tool and not some excess strategy for liquidity, not a way to just bring marketing or something of that sort. This should be your focus when launching a token. And the last point I'm going to discuss today is kind of a model you can take home and think about. You want to, let's say you're building the protocol, right? You're building some smart contract or protocol that runs on the blockchain. You want this level to be public and decentralized, and people be able to tap into this service and build basically kind of businesses on top of that. And these applications or user interfaces can be a private business, can work, not be kind of a decentralized entity, and have all of what you're building before, meaning the incentive mechanism or things on the decentralization level, support this thesis. So what we argue is that on the protocol level, if this is decentralized and the level above allows any person to kind of tap in and create these businesses on top, it will also improve decentralization there and can divide incentives between the two. Yeah, thank you. Question?
Yeah, thank you. I think that's an important part of the Web3, the legal side. I wanted to ask you about sanctioned addresses. So if you have some protocol, some product, is there some framework already how you can handle not interacting with sanctioned addresses to not appear in some lists for some regulators?
So you're asking how can someone actually enforce or mitigate that risk that I discussed by blocking or limiting problematic addresses, let's call it. So yeah, the main way to do it is on the UI front. And this relates to the last point that I discussed, is we argue that because these protocols are open sourced, free for all, you can't limit someone from interacting with it. What you can limit is the level on top from interacting with the UI of Uniswap, right? But people can interact with Uniswap in other ways if they're savvy enough. So this is the way to do it, and then the legal argument is that because that underlying level is decentralized, one can say that this is kind of a public good, so you don't necessarily regulate the street the same way you regulate a store that is on that street. So this is the argument. Yeah.
Thank you.
Hey, cheers for the presentation. Can you go into Mika a little bit and the sort of changes, both in terms of the travel rule that we've already seen in Europe, but also the changes that will come into effect in next year with Mika? Yeah,
so I won't go into that too deep, but we know that Mika greatly tackles kind of the custodian part of it, right? The centralized. It does a great job of that. It's very savvy. It doesn't really cover a lot of decentralized entities, so the Uniswap of the world and DAOs, it's not really clear. It covers a lot of issuance of stablecoins. And also it talks about launching tokens. You have to file a white paper. This is pretty clear by the law, but as I said, because there's another year for it to come into effect, we don't really know how the playbook will look. Add on top of that is that enforcement will lie in each individual state. So there's another level of uncertainty. I would say that for future, like Coinbase, Kraken, operating in Europe, these custodians, it's much clearer. Even more true for stablecoin issuers. Great work. All of the decentralized part, we'll have to see.
Thanks for the presentation. I had a question about data retention. So let's say that my service needs to maintain some database with some private data from, let's say Kraken, right? I might have some private data for each customer, let's say. What are the regulations in this sense of what authorities can force me to give them access to? I guess this changes also between jurisdictions as well, but...
yeah, well, again, when you talk about a service like Kraken, the conversation shouldn't be much more different than just any other service. But when you talk about some, like generally information that's stored on the Ethereum blockchain, which jurisdiction should enforce that? So, and obviously it's addresses which are not personal identity or identifiers, but what if there is in the future with ZK and stuff of that sort? And this is a world that is ever changing. We just saw an article by Vitalik. Yeah, I don't have much to give you on that front. We work more with DAOs on decentralization and token launch, but there's an array of different legal topics for many lawyers to tap in.
Maybe just a quick question:
Yeah.
if you had to open a Web3 startup, where would you open it? In which is the
Where in the world?
jurisdiction? Where in the world? Yes, you're free to go everywhere you want.
Yeah, so
You have a lot of money, I guess.
yeah, I would definitely not optimize for like jurisdiction selection. There are, Portugal is good for crypto, Zurich is good for crypto. These are fine. I would first try to find a place where you can actually build a company, so you can bring talent, you can bring money. That should be your focus. And once you're big enough, you can later do the most elaborate schemes of opening a foundation, launching a token. We all move to a different part of the world. You will have time for that. But at the start, you should focus on making the best product exist. And if that means being in Europe next to your hometown because you know all the developers and all of the ecosystem, then you should probably do that. Okay, thank you.
Welcome, everyone. My name is Felix. I'm a researcher at Howe Protocol, and today I will talk about how you can become a solver for Howe Protocol. My workshop will have roughly 3 parts. First, I will give an overview of what CowSwap is, what Howe Protocol is, what a solver is, and maybe motivate you to become a solver. The second part is about building a solver. So I will try to do some live programming. I hope it works. Where I will basically show you a solver template that takes care of a lot of the boilerplate of building a solver. And yeah, I will just add a small dummy solver and show you how you can then later use that template as well to build your own solver. And the third part will be about the steps that would follow. So if you have built your own solver, what are the steps to actually participate in the real production competition on Howe Protocol? So how to actually deploy a solver. Let's start with CowSwap. Who of you has used CowSwap before? Who of you knows what the solver competition behind CowSwap is, more or less? Who of you has maybe already tried to implement a solver? Okay, so only people from Howe Protocol, essentially. And okay, and another question. Is someone here in the business of liquidity provision or somehow building a DEX and not necessarily building a solver? Okay, no one. Okay, so then, hopefully you'll all learn in this workshop how to go from knowing about the solver competition to actually maybe implementing a solver yourself. And okay, so you all know CowSwap. So I don't have to talk about that too much. I mean, it's just a UI for swapping currencies. And the UI looks really similar to what the competition does, 1inch or Uniswap. But behind the scenes, there's a lot more going on. So behind the scenes, we are not creating directly a transaction from your swap intent, but we collect intents. So all the people who come to, for example, CowSwap, but also, I mean, maybe use other means of providing us with their intent, we collect it. We create what we call a batch auction from it. So essentially, we create an order book with all the intents. This order book and some additional information is sent to entities we call solvers. Those solvers compete for providing the best execution to our users. And in the end, one of the solvers wins, and that, I mean, the execution they chose is then actually transmitted on chain. So there's a lot of stuff going on. We collect intents, and you probably have heard a lot about intents already at Dappcon. I'm not going into detail on that part. Then there's the middle part where we have an order book, send it to solvers, and they try to find an execution, or try to fulfill those intents. And the second part is what we are going to focus about. So suppose we already have some order book. What does it mean to provide us with a solution? How do we choose the best solution maybe, and how it is then later ending up on chain is not really the focus of the talk. Okay. What do we mean by batch auctions, and what do we mean by a solution to batch auction? And solvers are then those entities who provide solutions. So what do we mean by a batch auction? What you should think of is an order book collecting intents of users who want to swap tokens. But it's, yeah, I mean, it could be just a really simple order book containing only 2 intents to trade, represented by green arrows in this case. One user, for example, wanting to sell DAI and who wants to buy ETH, and another user maybe wants to sell ETH and buy cow tokens. So we collected the intents, the solver gets those intents, this order book, and now what is the solution? And what solvers try to find is counterparties for those intents. So they want to satisfy those intents. And one really simple thing a solver could do is just pick one of those orders, not all of them, just one of them, and try to match it directly using some balancer pool or whatever. So that would be represented in magenta here. One of the user intents, solver decides, okay, that intent I want to satisfy just directly by matching it, for example, using Onchain liquidity, using an AMM, balancer, Uniswap, or whatever, or even private liquidity. This is what happens to some degree with competitors who just look at individual orders and try to match individual orders, maybe using a more complex route, but okay, that's what the competition can do as well. What is special about Cow protocol is that we have batching, so solvers can provide settlement or can try to satisfy the intents of traders on our platform simultaneously, so multiple intents simultaneously. And one way to also satisfy maybe both of those trading intents is to close this third leg here and create a ring trade. So someone selling ETH for cow, well, let's start here, someone selling DAI for ETH, someone selling ETH for cow, and maybe some AMM selling cow for DAI. That's a way to also satisfy those 2 intents, but it's potentially more efficient because it can satisfy both intents with just one AMM interaction. So this is what some other solver could propose, and the proposals of the solvers can get way more complex. Just one example, instead of settling directly those 2 intents by going from cow to DAI, someone else could propose a more complex routing because maybe the cow USDC pool is deeper than the cow DAI pool, and then swapping those stablecoins might be, frictionless essentially. So some other solver might propose such a route. And what we then do is we collect, after we have sent the solvers some of the order book, they send us their solutions, then we pick the best one, and this gets executed. So we pick the best solution, and the solver who provided the best solution is also rewarded for that. There are some rules around what is actually allowed as a solution, and also, the most obvious would be, users sign an intent to trade, where they essentially say, I want to swap DAI for a WETH, but the exchange rate has to be at least as good as this. So, the execution proposed by solvers has to satisfy that, for example. One additional rule we have that leads to more fair executions and also MEV protection that is not so easily done if you don't have batch auctions, or it's a thing we want to enforce if we have batch auctions, is that there's one price per token. So all users trading on the same token pair, for example, get the same exchange rate, which immediately makes sandwiching attacks within Cow protocol impossible. And also leads to some other nice properties with regards to MEV protection. And there are some more rules, more subtle rules, which you can find in the documentation. What we what the routing or the matching of the solver sensors has to satisfy to be a valid solution. And then in the end, there's still a problem of choosing the best solution. That's also a bit of a vague concept maybe. And the implementation is a bit subtle, but really think of who provides the best prices, or if multiple orders are involved, it's not just prices, but who provides most surplus. So in the sense of, if you have a lot of sell orders, who can provide more buy tokens compared to the limit exchange rate they specified. And that's collected over all orders, and then who has most total surplus or provides most total surplus to users wins. And okay, that's where the magic lies. Finding routing that actually provides users with most surplus. And then there's sometimes a trade-off between maybe just settling one order can already provide a lot of surplus. Maybe closing the ring trade is more efficient because you only use one AMM and can fill 2 trading intents. Maybe using more complex routing is better, but that might also increase gas costs. So there's also somehow some inefficiencies introduced by more complex routing. And in the end, it's mathematically speaking, a really complex problem. There's no simple algorithm for finding the best execution, and that's why Howe protocol outsources this finding a solution to this decentralized solver competition, where every solver can come up with their own algorithm, and in the end, we just compare solutions. So we don't try to find a solution, we just wait for you to send us solutions and choose the best one. Okay, so that's how the general idea behind the solver competition. And now I want to go do some live coding of implementing a really simple solver. And if you want, you can also follow along. So there's a GitHub repo for those interested, where you can scan the QR, or it's Howe protocol /solver-template-pi. So it's a solver template implemented in Python, where you can where it will show you where you have to add some functionality to actually make it a solver. But most of the boilerplate is already there. And okay, so let me go to that GitHub repo and show you how to proceed with building a solver. So this is the GitHub repo, Howe protocol solver template. Let me maybe make it a bit larger. And okay, so one thing is clone the repo. And after you've done it, you can either run it using Python directly. What I'm going to do is use Docker to run it. So I'm essentially copying that command to build a Docker image of the code that is already in the repo. I can run it like anyone would run a Docker image. And then I will explain where to add some functionality for the actual solve. So let's copy that and add it here. So for me, it's a bit faster because I already built it before. So for you, it might fetch a Python Docker base image, then install some requirements, and then you have a Docker image you can run. And let me run it. Okay, then you can run it like this here. And let me how was it called? It's called test solver image. That's it. Okay. So what this does is it starts an HTTP server on some port, and to that server we can now send order book JSONs, and hopefully by the end of this workshop it will also return something. Okay, let me briefly show you some of the code structure. So to just give you a really rough overview, so this Docker container starts a server which has a few endpoints, some checking for health, getting notified about results of auctions or how the auction we sent was ranked. But what is most important to us at the moment is this solve endpoint. So using that solve endpoint, we can receive a JSON containing the order book and maybe some additional information, some meta information about the state of some Uniswap pools, for example. And then what this does is it parses the request into a batch auction object. And so that's, we won't change that today. And then it potentially solves something. So let's comment that in. And then at the moment, it just returns what we call a trivial solution. So it says no orders matched, and that's it. And then it returns that thing. And okay, let's save that and rebuild the Docker container and run it again. So we have this HTTP server which processes a JSON called some solve function. That function at the moment is not doing anything. That's what we're going to fill. And then it creates a JSON file that is returned as a solution of the batch auction problem. So what we are going to do is we are going to fill in some simple method for the solve so that it actually does something with the order book. And then return the solution in the correct format. So, okay, to repeat, what you have to do is look at this solve endpoint, implement something for the solve function, and then convert it to the correct format to the correct solution JSON format. And there are some, I'm going to try to implement a really simple solver now, just a dummy solver. Feed it some test instances and see if the solution that it returns makes sense. Show you how to run a local test environment that already fetches correct, or the actual order books from that are also used in production, feeds it to our solver, and then we can see what it returns locally. That's the goal for this live programming session. So there's already a lot of additional code here. Won't be able to explain all of that, but there are a lot of utility functions you can use to make writing the solver a bit simpler. What I'm going to do now is try to write a really simple solver that just tries to, just goes through the order book, looks if there are two orders in the opposite direction, that can be matched directly with each other. And if that's the case, return that as solution, otherwise return nothing. So this self is an order book instance, and okay, has some fields. What we're interested in now is orders. Let's store that in orders. And what we're going to do now is loop through those orders and try to find a match. So for order I in orders, so this is not the most efficient way to do it, but just to to give you an idea of how you can work with orders, how you can try to create a solution. Okay, so we are looping through all pairs of orders, and now we want to try to find a match. For that, we could, for example, use this order I type and maybe explicitly ask, is the byte token of order I equal to the cell token of order J? Is the cell token and vice versa. What we can also do is use, to make it a bit faster, to use some utility functions already contained in the code to see if an order can be matched. So there's a match type functionality that you can apply to two orders. And the result is somehow an enum that tells you, can those orders be matched? Can those orders be matched partially only? So that should be, is it a match as a order match type, hopefully? Oh, let me check. Order match type, and it's both filled. Hopefully. And okay, so just a really simple cow finder. If orders can directly be matched, try to find it. And just for debugging, before we add more code on how to actually construct the solution object, let's just try to run the server with that code and print aloud moo. Let's see. Okay, and now we have a solver that does something. At least prints a moo if there's an order that can be matched, and now we can feed it test instances. And those how to feed test instances is also contained in the GitHub repo. So let's just try that out. Let's rebuild our Docker image and run the server. And now we can look at the GitHub repo, and it contains somehow a command to just curl it some auction instance, also contained in the GitHub repo. So I'm just going to copy that. It's a really small order book instance that is somehow designed to be easy, that contains two orders that can be matched directly, and hopefully, if nothing went wrong, the code will actually produce a moo. It will still return the trivial solution, the empty solution. We didn't change that yet, but it should at least detect that there is a potential cow. Okay, so we have our web server running. We try to feed it order, and there's a wait order match type.
Probably you have to import it.
What?
Maybe you have to import it.
Ah, okay. Order match type. So, I think it's here, order match type. Okay, hopefully that works. Otherwise, yeah, I mean, there's also pull requests on this GitHub repo for two simple one solver that essentially does what I'm doing here, and another one that just tries to match an individual order to a Uniswap pool. But let's go back to the code, and let's try to run it again. Whoop. And now let's feed it the request. What it returns, what we see here, it returns, I mean, I also print the return, so it's a JSON, but it's, contains, it's not an empty JSON, but it contains no orders, no prices, no AMMs, and so on. So it returned the empty solution. And here we should see a moo, okay, because I did this inefficient double loop, it finds a moo twice. So at some point, okay, after the first one, it should just return. So it only finds one moo. Okay, but then, okay, after we found a moo, we can actually construct a solution now that matches those two orders, where we have to specify what are the amounts that are exchanged between the orders, what are the valuations of the different tokens that define exchange rates, and maybe I just copy it from somewhere to make it a bit faster, and I mean go through the code and what it means. So what this does now is, okay, after it has found the cow, uses the execute method of order I and j, and just sets buy amounts and sell amounts to the order, or to the amounts of the matching order. So that has to be done for both orders. So this is one part that is important for the solution solvers return to us, that they specify which orders are executed and what are the amounts that you propose to execute. And the second thing is that you also have to specify prices. That's not so important in the case of just a single cow, because they just trade one-to-one, but if there's a more complex, I mean, maybe a ring trade between users, or more orders being settled, it's important to actually set the correct valuations for the different tokens. And what this code essentially does is, okay, token A is the sell token of the first order, token B is the buy token of the first order, and then you set this, the values for this dictionary self prices for the different tokens, for token A, token B, and set it to, in this case, the sell amounts of the different orders, which, if they are matched one-to-one, define the exchange rate. And that can be coded, or is encoded using prices, for example, like this. Okay, and there's already a return here, so we don't need that. okay, now we have implemented some logic for, after we found the cow, how exactly which orders are matched and how exactly are the amounts these orders trade. And because we checked that the orders actually can be matched, we know also that limit prices are satisfied. Yeah, so that should result in the end in a valid solution. Yeah, for the solvers you write, you probably have a more complicated logic at that point. And this solve method is where it goes. Next step would be to actually return that solution. So we are still, we are calling the solve function. So yeah, the batch object is updated. There are now prices, there are orders that are executed with certain traded amounts. And now we, maybe rename this to solution. And now we have to fill some of those dictionaries in the JSON with the actual things we want to do. Let me maybe first remove some of the things we don't need for now. Okay, let's keep the AMMs, but we're not using any AMMs. We're just matching two orders directly with each other. And now we have to turn that, the information in the batch object into a valid JSON. And those orders and prices are dictionaries. And let's create those dictionaries. So for order in batch orders, if order punct is executed. So I'm looping through all orders now, and what I'm doing is I'm creating a dictionary that contains order ID as key and contains the order as dictionary as value. I'm not going to go into detail on what the specification of the return format is. You can look it up in our documentation. Okay, so orders is a dictionary where we have keys, order IDs, and then using this utility function, we can create a dictionary, the correct format from the order object. And for prices, something really similar happens due to the values being stored in a slightly different format. It's slightly different, or so we loop through all prices. Batch prices, which is a dictionary, so we loop through all items in that. So we have the key value pairs, and what we do with them is we take the key and make it a string as key of this price dictionary, and then convert the value to a decimal in string format. Fortunately, the repo already contains lots of functionality around converting to the correct format, so that you don't have to fiddle around with the different representations as. Okay, so I guess I have to import that as well from somewhere. Oh no, I have 4. No, okay. So that should hopefully produce a correct JSON format. So let's rebuild the solver server and try to feed it the instance from before. It should find a cow, should print aloud moo, but also return some actually valid solution that contains those two orders and matches them. Okay, let's see. Let's just send in the same small example test instance contained in the repo. Internal server error. Okay. Okay. I actually should have imported that from somewhere. Let's see. So I'm not sure from where. From let's do it like this. Okay, now when I send the order book to the solver, it returns something which looks like this. So it's a JSON containing orders that are contained in the solution, and okay, some meta information on the orders, but also what we call executed amounts, so the actual amounts that you specify as a solver this order to trade. And okay, so we have built a really simple small solver, and one thing. So how much time do we have? Okay, one thing we can now try out is run some of the infrastructure that Howe protocol runs off-chain locally to fetch the order book from Howe protocol, send it to our solver, then return a solution to our local version of the order book, and see how this local server responds. And for that, I can let that server run. What we're going to do is what is next in the GitHub repo, connect to the order book. And what I'm going to do is just run a Docker container with exactly this this command here. You can, so let me copy. And okay, there's no env file, so this this Docker container uses as input some environment variables, and at the moment, so let's copy the sample environment variables. So copy .env sample to .env, and let's also have a look at. And okay, let's start the server. It should start now, and let's have a brief look at what the what is contained in this environment variable file. It contains the URL of the local solver I'm running. So it's okay, just a local host on port 8000. It contains a URL for an order book. What I'm using here is the order book for the staging environment or test environment on Gnosis chain to make it a bit easier and cheaper to try out stuff. And since it's a test environment, so instead of swap.cow.fi, you can submit orders at barn.cow.fi, so there's not that much traffic, so you can also submit orders yourself, and there's not so much noise, so you can observe how your solver handles your own orders you submit. And yeah, okay, some other information about nodes, and so the rest is not so important. Okay, we have the server running. We told it to send auction instances to this, to some URL on some port. And what we should see on our solver server that we implemented is that it receives instances of the order book. And so you see, receives an instance every few seconds, but never finds a cow, because at the moment there are, we can look at the order book. The order book on this dev environment on Gnosis chain only contains 4 orders, and none of them can be matched in a cow. And if they could, probably some of the actual solvers in production would match it, so it wouldn't be there for long. But okay, what you see here is that at least our solver receives the order book, sends something in return, and what you also see is, we get those solve post requests, but we also get post notify requests, so responses from the driver component or from the order book component that tells us what happened to our solution in ranking. And because we didn't find a cow, we always get rejected because we only sent the empty solution, which is expected. But now you could, submit orders to the order book via barn.cow.fi, and potentially submit orders in a certain way to actually create a cow, create something that our solver can also find. So in principle, we don't really have the time for that now, but if you now go to this testing environment, barn.cow.fi, so there's really a test environment, but you can actually trade real tokens there on Gnosis chain. And if I just do some trade west to GNO, I can confirm the swap. I can sign it. This is not a cow. It's just one order. So to have a cow, you would all maybe have to spam orders on the West GNO pair now. But what you can already see is that hopefully, if you look at the this order book component, is that now there are 5 orders in the order book. So before there were 4. Now there's 1 order added, and maybe at some point, okay, the trade happens. So now at some point it should go back to 4 orders in the order book. But that's one way to try out your solver locally, where you already use the real order book, but you don't actually send solutions to us, and what you send is never executed, but just to try out your solver with actual real order books. And Gnosis chain is, there you can also easily submit your own orders and try around or try out some stuff. You could also, if you change this end file, use the order book from mainnet and use some inferior node to fetch blockchain data to let this order book run, and then test your solver with mainnet, within the mainnet order book. Okay. So that hopefully helped a bit to give you an idea of how to implement a solver just from the technical side. So start with the order book and start with a template, with a Python template, fill in the, we can switch back to the presentation. So the main things is fill in the solve method with something that you come up with that is potentially more efficient or better than what the competition does, so you can actually win the solver competition. Convert it to the correct solution format, and that's already a good start to get you running. But what are the next steps? What I would recommend is that the next step is to contact the core team. It's not strictly necessary, but for some of the next steps it is. So, I mean, some of the contact information is on cow.fi. A special mention goes towards this solver Telegram group, where some of the production solvers, but also lots of people interested in writing solvers, but also people who maintain or develop DEXs, other DEXs, AMMs, who want solvers to integrate their liquidity. So lots of people in that Telegram channel. You can ask questions if you want. Another good place to go is Discord. So contact the core team. The next thing is also, I mean, probably don't have to tell you, but the next thing would be more testing. One thing is you can actually look at what the competition does. So, I mean, we have an API for various things, but one thing you can do in the API is actually look at solutions sent to us by all the solvers. So if you have a transaction hash of a finalized settlement, you can use our API to get information on the solver competition. And for this particular transaction hash, there's some information on orders and prices and so on, but what's probably interesting to you is that there's an entry for solutions. For this auction, 10 solvers handed in a solution, and so they are ranked by best solution comes last. So then you see which solver actually executed, or which solver had the best execution. You see what call data they actually submitted to chain, and okay, that's public anyways. I mean, it's on the blockchain. But one interesting thing is that you can also look at what the runner-up did and what call data they provided. So you can try to learn from what the competition does, what type of routing they use, or if they specialize on cows, like in my simple solver, or So solvers are free to do what they want, and there you can get an overview of what they do. So that's, okay, for that you don't need to contact us, but one really useful step is what we call shadow competition, where once you have a solver that is somewhat reasonable, you come to us and say, hey, I want to try out my solver. Then you give us a URL of some web server where we can send auction requests, so those solve post requests, using really the production order book. You send us back your solution, it gets ranked compared to all the other solvers participating in the solver competition, and in the end you can see what would have happened. So we don't actually execute anything, so it's relatively risk-free, but that's a really natural next step after you have tested your solver locally. One other thing that at that stage you should look into is what we summarize as bidding strategies or revert risk. The mechanism we use for rewarding solvers is based on, it's an auction mechanism. And so it's based on how much you are better than the competition. And you can, for example, also say that things like, if you win, you want to get paid at least this much. What is noteworthy is that if you revert, so if you propose a solution, it wins, but for whatever reason it uses so tight slippage tolerances that it can't be executed on chain, you will be penalized. So there's a monetary penalty for not providing a solution that can actually be executed. So at that point, you should be aware of revert risk, use bidding strategies where you say, okay, I hand in my solution that provides lots of surplus, but due to maybe the risk of not executing, I want to get paid at least this much to make up for it if I win. So and at that point, it becomes a bit, you have to invest a bit more brain power into how you communicate to us what you want to do with your solution. So it's not just which orders gets matched to what, but also, it's really an auction where you bid for getting the right to execute. Another thing that is noteworthy is that there are some rules. I mean, I mentioned 2 rules, like limit prices of the orders have to be satisfied, so the intent has to be satisfied, and all users have to trade with the same price on the same token pair. There are some rules where we don't know yet how to formalize them into our smart contract, and for some rules we don't even know how to necessarily formalize them even in some off-chain component. So we have some social consensus rules that we don't strictly enforce before you send us your solution, so we don't filter out your solution based on it. But if we see that you are intentionally providing worse prices than you could to our users, then you can get penalized as well. So having a look at some of the soft rules of our competition is something you should do after you've tested the hard rules by submitting solutions and seeing if they get ranked. Okay, that's probably not a lot of news to you that you should do more testing, but what comes after you have tested enough? How to actually deploy your solver in production. What we do is we require a bond from solvers. Why is that? Solvers get access to funds in our settlement contract. So for example, we collect fees in our settlement contract from users to cover execution costs, and potentially a malicious solver could try to steal those fees. So we have a mechanism to prevent that, which is you provide a bond, and if you misbehave, we slash you. It is decentral in the sense that if you actually are able to provide that bond yourself, you can just participate. It's not, no one can, the cow DAO has to allow your solvers into the competition. But, okay, it's a high barrier to entry. 500,000 USC, 1.5 million cow tokens. Most solvers don't do that, or almost all solvers don't do that. What we also have is already existing bonding pools. So one bonding pool maintained by Gnosis and another bonding pool maintained by the cow DAO. And what you can also do is try to make those bonding pools accept your solver or vouch for your solver. But then the bonding pool can decide on additional rules. And what, for example, the cow DAO bonding pool does is, it requires some light KYC because the cow DAO's funds are on the line if servers misbehave. They also have to show that they provide some value to the competition. So we don't, there's no value necessarily in having lots of solvers who don't do much. So my solver wouldn't be added to any bonding pool because other solvers can do that as well. So what you typically would have to do is tell us that you want to join us. We add you to the shadow competition and see, okay, can you actually win the competition sometimes? You don't have to be super competitive, but you have to show that there is some value in you participating. And then you also, we test you a bit more in this dev environment, for example, before we move you to production. And okay, some other restrictions as well. So I mean, you're rewarded for winning auctions, but if you join this Howe DAO bonding pool, some of that reward will be locked for some amount of time. Okay, but that's somehow, yeah. After you set up your solver, after you've tested it enough, again, contact the core team and try to be included in one of the bonding pools. The simplest approach probably is to, yeah, try to be included in the Howe DAO bonding pool, and then, yeah, that includes additional restrictions. Okay, just to briefly summarize what I talked about. Okay, I talked about what the solver competition is. So solvers try to match user intents as good as possible. Who matches it best wins. I talked about how you can build your solver starting from a template, and the essential part is you only have to define that solve function. But okay, what you put in there is somehow there's the magic, and yeah, that can give you a competitive advantage. And then I also talked about what the additional steps are to actually deploy your solver in production. And now we have a few minutes for questions. Yeah. And there's a microphone going around.
Do you find that the majority of the solvers that win the competition, is it 1 or 2 or 3 solvers that are just far ahead of the competition, or is it really quite well spread, distributed?
Yeah, good question. At the moment, we have around, let's say, 10 to 15 solvers who participate. I mean, just last week, the solver who won most auctions won about 20%, 25% of auctions. So there are solvers who win significantly more than other solvers, but it's not like 50%. And yeah, the solver who got most rewards in the solver competition, so rewards are based on how much you improve upon the second best, that solver won about 10 to 15% of auctions. So it's not just about who wins most auctions, but also about who can actually provide most utility to users. So the marginal utility you provide upon the second best.
Yeah, you answered my question already.
Okay.
How many bonding pools are there currently?
At the moment, there are 2 bonding pools, one by the Howe DAO and one by Gnosis. Yeah, we try to get more solvers to put up a bond, but yeah, it's a large barrier to come up with the funds. But yeah, I mean, some solvers indicated that they would also create new bonding pools, but at the moment there are just 2.
Perfect, thanks.
Hello. I know Yearn made their own solver to make it easier to trade their vault tokens. And so my question was, would that logic be in this solver here or part of the cow swap hooks, or where are those other kind of DeFi interactions happening to help trade these more complex tokens?
I think, I mean, so I'm not sure. Maybe I should refer the question to the backend people, because I mean, Yearn did it before we had hooks, so potentially it's possible to do it differently. I mean, what I showed you is just this: there are orders and you execute orders. What you can also do is we send you some AMMs, and you can say, okay, I'm picking that AMM and I want to trade this much tokens. But there's also a thing that I didn't show, which is called interactions. You add to the settlement, and there you can, yeah, essentially include any call data. So you can also, yeah, use, yeah, other or yeah, call other smart contracts, for example, and do other things besides just transfers of ERC20 tokens. But if you have further questions, there are people in the back who know all about hooks. Any further questions? Yeah, if not, then yeah, thank you for your attention. I hope I could convince you to start searching for better prices as a solver, so our users don't have to. Thanks.
right. Hi, everybody. My name is Eric Tang, and I'm the co-founder and CTO at Livepper. Thank you for being here. Today, we're going to talk about building on-chain media applications. So we'll do a little bit of a technical overview of what on-chain media means, and specifically go into how video streaming works in an on-chain environment. And then we'll do a little bit of a live demo / live coding to see what it's like to build an on-chain video application using Livepper. And then we have our head of ecosystem, Shannon, here as well, who will tell you a little bit more about opportunities to hack with Livepper and participate in the Livepper ecosystem. Cool. All right. I don't think this works. That's okay. Okay, so a little bit about me. I've been working in the tech industry for over the last decade or so. I started out building an application called Hyperpublic. In 2010, it was acquired by Groupon in 2013. I kind of saw how a fast-growing application looked like from the inside, and how people were activating like a huge audience. And then I started another company called Wildcard. Wildcard was a mobile application as the App Store was just starting to take off, and it was one of the Apple's app choice of the year in 2015. We kind of again saw how mobile application was working and how to get users to adapt your application. And then in 2016, as Ethereum really started to deploy its AlphaNet, I started working with the Ethereum Foundation on some open source projects, and then we kind of started working on video streaming in the Ethereum ecosystem, which then became Livepper. So yeah, we'll get into kind of on-chain media. So what is on-chain media? The big media has always existed. Video streaming has always existed, right? But the big foundational change for the blockchain at the intersection of blockchain and video streaming is the fact that prior to the blockchain, if we wanted to share a video, we have to first upload it into an application. And as soon as that video is uploaded into the application, it is now constrained by the context of that application, right? So I am uploading a video into YouTube or into Vimeo, and I'm sharing the application's link in order for other people to watch my video. But the video is going to be stored in the database of that application. It's going the way that people interact with that video, the way that the video is monetized, all of those things will be constrained by that application. So the kind of the creator and or the content rights owner of the video kind of lose control, or they have no choice but to opt in to lose control in that situation. With the blockchain, it kind of turns that paradigm in its head, right? So with the blockchain, when someone is publishing a video, you first publish that, you create a record on the blockchain, and you use decentralized content network to distribute that video, right? And now applications can be built around that, and applications will essentially be loading that data and just being kind of an interface between the content creator and the audience and the users of those applications. And that puts control back into the hands of the creator of the video. The creator should be able to define how they monetize the video, how they control access to the video, and all the different logic around how the video or how the media is consumed, right? And that's a pretty exciting feature, right? In this way, the media and the video itself becomes the platform, instead of like these centralized platforms that then are controlled by all these big corporations. So So yeah, we talked about blockchain as the public ledger for the media itself. It now gives us proper content ownership and licensing that's controlled by the creator of the videos themselves, and that then creates a much better economic relationship between the user and the platform. So why are we focusing on video today? Well, video is about 80% of all the internet's traffic today. And so for blockchain technology and for dApps to really gain mass adoption, I think it's important for video streaming to be working in this environment. We'll go through some high-level technical components of on-chain video today. So there's a number of topics here. We probably won't go into details for every topic, but I'll kind of gloss over some of the different technical areas of consideration. On-chain representation of video, right? First, when we publish video on-chain, it has to be represented somehow on the blockchain. Today, most of that data is represented by NFTs, right? So think of NFTs not just as a PFP, but really as a reference pointer to a piece of data that's off-chain. And once you have that reference pointer, you can start to use smart contracts to control it and to manipulate that data. However, only a reference pointer is sometimes not enough, right? So today, NFTs really just represent like ownership of that data, right? The creator of that NFT can say, when they write the record on chain, they'll say, I'm the creator of that, I'm the owner of that data. And then if I wanted to transfer ownership, then someone can pay me for that transfer. But that kind of loses some important context for the video as a piece of media, right? For example, the provenance data. We want to know how the video has evolved over time, right? Maybe I created the video on my phone, I uploaded it, and then Shannon made some cuts to the video. Someone else did color correction, editing, right? That provenance chain is oftentimes very important. So having the blockchain to be the ledger to record that provenance data can be another really powerful thing. And once we have all that data on the blockchain, there needs to be ways that we can verify the ownership and the provenance data for the video as people are watching it, right? So we've been working on this project called the Verifiable Video Project, where where Merkleized proofs are generated with the video, so that as you're streaming the video, you're also getting the proofs being streamed to you. So as you're watching every little segment of the video, you can prove, your video client or your computer can prove that it's coming from the video that you requested for, right? And no one has manipulated the data in the middle. And that UI component is very important for users to gain trust that this piece of on-chain media actually has authenticity to it, and I'm actually watching this media that was created by this owner and then edited by this person, and so on and so forth. And with that comes content distribution and data licensing, right? One important thing about video streaming is that it needs to work at scale, because oftentimes lots of people are watching the same video, right? Good example, Game of Thrones, one of the most popular TV shows. Lots of people are watching that at the same time. So whatever infrastructure is delivering that video needs to be really performant and needs to be really scalable. And that's really hard to do in a decentralized context, and that's something that Livepper has been working on for the last 7 years. And if we combine access control to this scalable decentralized video streaming infrastructure, now we have a decentralized way to do access control. And that's quite interesting, because that allows us to use smart contracts to control who gets to watch the video, right? So for example, a really common use case here is token gating the video, right? So someone can only watch the video if they own an NFT or they belong to a member, they belong to an on-chain community. But it goes way beyond that. Access control is a pretty powerful thing, and there's people have written pretty powerful access control engines around controlling access based on geography, based on subscription, based on tipping, based on time, right? All of these things, and that's important for this infrastructure to be able to enforce. Another pretty interesting development that recently happened is this universal data licensing that's happened in the Arweave ecosystem. So this is this concept is saying that most data should have a license that attaches to it. However, currently on the internet, over 90% of the data do not have a license attached to it. So what that means is it's very unclear. It's very ambiguous on how people can actually use that data, right? But if you are uploading video into YouTube, for example, you just use YouTube's license, and that oftentimes is not what you want to do as a creator. So universal data license allows the creator to pick the license that they actually want to have, and it allows that logic to be enforced by smart contracts. A simple example is splits, right? If I have published a video, and if some application wants to charge for watching that, for people to watch that video, they can share 10% of the profit to me, right? And all of that is kind of encoded in the license itself and can be automatically ascribed to. The next topic is about, once we have scalable distribution and proper kind of license management, we can have like direct interactivity between the creator and the consumer, right? And this is one of the powerful things for blockchain is that the application starts to lose some powers to the creator and the consumer, right? So these are on-chain communities around media. We can have ultra-low latency live streaming that enables real-time chat that for the creator to be able to stream video to their community directly, and for their community to gather around that content using the blockchain in a grassroots way and start to interact with that creator. And the other thing that I would say here is that it's really powerful because it unlocks the creator's community, which is oftentimes the most valuable thing for the creator, right? The creator now, if they built up an audience on YouTube, well, they're locked onto YouTube. When they move to a different platform, they cannot take their YouTube fans with them. In this on-chain world, because the community is revolved around the media that's on-chain, it doesn't matter which application they speak to with the creator, the creator can kind of move from application to application without having this platform risk. We talked about some of the smart contract components here, right? The last thing I would mention here is the on-chain advertising component. Oftentimes people kind of don't want to talk about advertising in this context, but advertising is actually really important. If we take away all the bad practice of today's advertising industry of data harvesting and things like that, if we just look at advertising as a way to promote media, it's a very important concept, right? That's the way for a creator to get their content out there and for other people to watch their content. It's through some form of advertising, whether it's social media or otherwise. Right, so if we move this mechanism on chain and create transparency around the way that people can promote their content, that becomes a really powerful and an important tool for this whole ecosystem. The last kind of technical topic I would just mention here is around censorship resistance and content safety and moderation. Right, so these are oftentimes somewhat contradictory topics, right? So oftentimes people say, well, if you have true censorship resistance, then you lose the ability to moderate content and vice versa. But in this world, it's actually very important to have content safety and have the ability for content to be moderated, at least for the communities, so that illegal content don't get spread and harmful content don't get spread. Right? So there are a couple of areas of technical innovation that's happening right now. One is the recommendation algorithm optionality. And oftentimes when people talk about censorship for big platforms, that's what they're talking about. As a creator, I'm beholden to the recommendation algorithm of a certain platform, of Twitter or YouTube or Twitch or whatever it is. If those platforms change their algorithm even a little bit, you see businesses being wiped out, right? Just by that change of algorithm. So in this Web3 world, we're starting to see applications that encourage different recommendation algorithms to be built within the same application, so that users have a choice to pick between them, right? And that reduces the platform risk for the creator, for the content creators, because different algorithms can be, even if one algorithm changes slightly, there are other algorithms that are also kind of providing traffic to their content. Related to that is front-end optionality. We talked about this a little bit, right? Different applications can be showing the same content. We'll get into some examples of that. Protocol infrastructure being incredibly neutral. This is very important, right? That this is, again, the core of censorship resistance. And because people shouldn't, like the builders of the protocol and the builders of the infrastructure should not be opinionated. However, the content safety and moderation tools can happen on the community level and on the application level, right? And that's oftentimes where things get a little murky, and especially when it comes to local legality or regulatory topics. The application builders should comply to those things, but communities that use these tools should also have their own kind of content policy. Right? So we talked a lot about abstract concepts. I want to dive into some real-world examples here. The first thing I want to share is something that happened pretty recently, called Onchain Summer Stories. So Coinbase launched a Ethereum L2 called Base in, I think, July. And as a part of that activation campaign, what they did is they created this on-chain summer concept, and every day during it was during the month of August. Every day in August, they interviewed a different builder in the Base community, and then they live streamed it, and then they had a daily NFT drop that kind of symbolizes the builder that they're featuring that day, right? It was quite interesting. So the first day, this was the kickoff between Jesse Pollack, who was the creator of Base, and Brian Armstrong, who is the CEO of Coinbase. And some interesting data here, right? They did 23 straight daily interviews with builders on the Base ecosystem. Of course, those streams were powered by Livepper and syndicated to other social platforms like Twitter and YouTube. They had very clear call to action in all of these interviews, right? So the call to action was to go mint the daily NFT drop, and you see because they were doing this at the same time every day, you see the audience coming back on a daily basis, and this was a very core component to a successful kind of community onboarding for the Base launch, to the point that in the month of August, Base became the most profitable L2 out of all Ethereum L2, right? More profitable than Arbitrum, more profitable than Optimism, who have been around for much longer than Base, right? And I would attribute a lot of that to this really successful campaign that built a really strong community, that got people to bridge their Ethereum to Base, go use all the Base applications, minted their NFTs. Another example is the Lens universe, right? Lens is a decentralized social protocol. They have many projects in their ecosystem, and it's pretty interesting what they're doing. So there's the social media applications, of course, but there's also tools and curation, and there are certain builders in that ecosystem just focus on algorithms, right? So here's an example of my Lens profile in LensTube, which is a YouTube-centric type of video sharing application. This is my same profile, but within a different app called Lenster, which is more of a feed style, like Twitter-like user experience. Here is my same profile featured in another application, which is called, I think, Diverse HQ, which is more of a Reddit style application where there's community they're encouraging community conversations, right? Kind of like subreddits. Here's an example of my profile inside Orb, which is a mobile app, I think a Flutter-based mobile app that has a really flexible UI, right? So this becomes really interesting because all of, me as a user of Lens, I'm oftentimes hopping between these applications depending on what's my use case. But I get to interact with the same social graph that I have, right? If I want to binge on someone's video content, I go to LensTube. If I just want to see what's going on, kind of scroll through a feed really fast, I go to Lenster or I go to Orb if I'm on my phone, right? And if I want to really dig into a topic and discuss with the community, I go to Diverse HQ, right? So if I consider myself as a creator in this context, I start to have all these different options to jump between these applications. Even if I didn't like one of those applications, that's no problem. I just use the other ones. I don't lose that much, right? Over the last year, right, Lens has built out about over 100,000 users, and they're still kind of capped. They're still capping the growth to combat kind of the spam and bot issues. There are hundreds of projects in this ecosystem. There's over 500,000 publications, right? So every post in Lens is called a publication. But the most interesting metric here is that there's already $350,000 that's been made by the creators. Right? The creators have made that much revenue in this ecosystem by people collecting their posts, tipping them, right? There's all these different ways that you can do on-chain actions that support creators in the ecosystem. Cool. Another quick example, we probably all know Zora, right? Zora is an NFT marketplace focused on open edition NFTs instead of some of the more traditional kind of speculative NFT marketplaces that focus on trading the NFTs, right? And this is a really media-centric play, right? So their concept is really about NFTs should represent on-chain media, and by minting an NFT, you're just kind of contributing to that media, right? There's 3.8 million mints that happen on this platform already, and they've captured millions in revenue from minting fees. For every mint, I think Zora charges a couple of dollars. And that's kind of caused them to take the next step, which is to launch their own L2, which creates a new business model for them to collect gas fees and collect more revenues that then they're recently starting to share that revenue with the creators. So they're doing this revenue split on the blockchain level, on the protocol level, which is quite interesting. It's a novel way to get around the problem of NFT marketplaces not enforcing royalties for creators. So we're starting to see these new kind of financial primitives that are happening on chain, right? So whether it's on-chain sponsorships, content promotion, which is advertising, subscription, or on-chain tipping, right? These are all kind of financialization of the content. We're even seeing content, there are people selling shares of the content, right? So all of these experiments are happening, and it's quite an exciting time right now. So so with that being said, I want to give a quick demo of a few things that we've been working on at Livepper that helps developers to build their apps. So I will jump over to, I probably won't have time to do the coding from scratch. So I will do this. Here's a guide that we've created for kind of hackers that are here. So I will start with this starting point and to show everyone kind of where we're starting. In this application, we are building a NFT video NFT minting app, right? So it's pretty simple. Allows me to upload upload a video, export that video into IPFS to be able to play it back using Livepper's streaming infrastructure. And then mint an NFT using that video. Right? So we will be starting from here. And if we look at this app, it's a pretty simple React app, right? It's just a boilerplate. I'm going to start adding some code into in here. First thing that I'm going to add is a upload button. And it should look something like this. Now I have a way to click on to upload a video. I'm going to add an input here. And add some reference pointers up here so that the logic gets hooked up, and then make sure I'm doing the right imports at the top, the file, and then I'm going to add this on-click action so that when this guy is being clicked on, it'll actually do something. And then in here, I would do this, and then I'll add a little placeholder button down here. So here now, we should see, right? So now I click on this button, it allows me to pick a video. Say if I pick this video, I should be able to upload it later. Okay, so now I'm going to skip ahead a little bit and add some more code, but I won't go through it step by step. I would do this here. And so this is probably a more built out application. You see there's a little more code that allows me to kind of do the upload, keep track of the progress of the upload, and play back the video. So I'll just show you guys how this works. So I'm picking this cat video. I'm uploading it into Livepper, and it starts to, and it'll show me this progress bar. Well, Wi-Fi here is a little slow. But yeah, as it's uploading, I should be able to see it in the Livepper developer dashboard. You see here, this video is being uploaded and processed. Here are some previous uploads that I have done. For example, if I go here, I can see the video should be playable once it gets loaded here. Yeah, live demo is always challenging with the Wi-Fi situation. Let's see, we're still 18% over here. Yep, so now it's kind of streaming this video. I can save it to IPFS simply by clicking here, and this video will be exported, and I'll get an IPFS hashback, and from there, this IPFS hash is what I would use to kind of mint the NFT, right? So here you see, it's pretty simple for anyone to build an application that allow a user to, upload a video and play it back in their own application and kind of attach that video on chain, represent that video on chain by minting an NFT. There's also ways for you to do access control of that video, and you can use that as a mechanism to, for example, do token gating. I'll show just one more thing here, which is more around live streaming. So this is an important feature in Livepper as well. So here I can go live with a click of a button, and yeah, we'll see. Yep, here I'm live already. So I can, for example, share this link with somebody else. They should be able to watch my video, and there's it's about 1 to 2 second end-to-end latency, right? So here I should be able to, if Wi-Fi allows, it should let me play my video. And there are a couple of other important things. One is that this also allows me to multi-stream to other platforms. For example, here I'm streaming to YouTube directly, so I'm streaming within Livepper here, and I am also streaming to YouTube. I don't know if I can even open this many tabs here because the internet's not very fast. But let's see if that'll work. Now we're going over to YouTube Creator Studio. Yeah, it's taking a long time to load. We won't wait for this, but yeah, the idea is that you can do multi-streaming. You can also record this session, so it becomes kind of video on demand files afterwards. And yeah, it's quite powerful. And you can also use token gating, for example, to gate access to this content. So people have built all kinds of interesting experiences around this, and this is actually one of the core features that Base used to build their on-chain summer stories campaign. Cool. So now let me go back to the application here. So I want to kind of pass the mic over to Shannon now, so she can tell us a little bit more about about how ways to collaborate with Livepper.
Do I need to? Oh, we're good. Oh, wow. Thanks, everyone, for sticking around. Thanks, Eric. My name is Shannon. I'm head of ecosystem. And yeah, I'm going to just quickly run through some of the other ideas to help you think about what you can build to bring on-chain video to on-chain apps. So Eric's given a really amazing overview of what's available today. A lot of the products that are in the Livepper ecosystem and that the core team works on are still kind of in development and areas for really open innovation and community contribution. And yeah, this is kind of summarizing the workflow for bringing video on chain. Eric's already gone over, a lot of these kind of features and primitives when we think about what on-chain video means: monetization, attribution, provenance, distribution, access control, processing and transformation, storage. I mean, these are all areas that we're just so early in this space around Web3 video applications. I think these are all parts of a fully decentralized stack for a video application that are still, we just love to see lots of experimentation around that workflow. So Eric already talked about the verifiable video project. Why are we pursuing that as an open, public R&D project that our engineering team is running? It's because, verifiable video, verifiable content authenticity is really important, both to solve challenges around viewership and making sure that when people watch video, they're not getting deepfaked. Verifiability is also important to enable new economic models for creator monetization through those provenance guarantees. So this is a QR code to the Notion repo that has all of the really deep work that the engineering team led by Eric has been working on to create kind of alpha tools for thinking about how you can work with video verifiability, whether that's creator-assigned video and attestation models, kind of the provenance chains and hashing that Eric referred to. I don't know, Eric, if you want to give a little bit of an update on where that project is and what for you would be priority areas that people can dive into, both to just help the tools advance and to start testing the tools.
Yeah, I think so. Where we are is that we have like an end-to-end workflow now where somebody can upload a video, create an attestation for the video, and then for that attestation to be seen as the viewer is watching the video, right? So an example would be, I create the video on chain, I attest that I am the creator of the video, or Shannon is the editor of the video, and all of that information is then passed to the user when they're watching this on-chain video. They can see in the corner of the video player that, they click on a little icon, it'll show some provenance information. The next step, of course, is to make this more robust in like the other ways that people can use it for, right? So something that we're exploring a lot is this idea of content remixing. So we all know that video content gets remixed a lot, especially in today's social media context. But those remixing don't really have economics attached to it, right? So if I edited someone's video and my video became really popular, well, the source as my video oftentimes don't have any attribution. And that's a big problem right now because there's actually a lot of people, they would just take video from one platform to another and steal the content to create a really popular account on another platform that then they get to make money and make ad revenue off of, right? So that's a big problem that needs to be solved, and we think the blockchain can create a tool that helps people do that. It doesn't even need to be its own application, right? It can be a creator-centric kind of content management tool that just allows a creator to back up all of their video from YouTube, from Twitch, from Twitter, from all these platforms to a blockchain-centric world where they can actually show the provenance. That will be the first step. And as soon as that becomes possible, there's video fingerprinting or all these new all these techniques that can help even identify those bad actors and in an automated way, right? So that will be an example. But yeah, there's also other ways of things like monetization.
I don't know if I'll break this if I click this link, but this actually goes to the verifiable video page just to give you a flavor. If this Eric is going to load, maybe like, oh my gosh, it might work. Yeah. You can see, yeah, some of the technical, the font is not very big here. But I mean, there's a huge ocean of technical topics to kind of dive into when you think about verifiability and content authenticity around video. One of them, just to like call out, because there's someone in the room working on this, is delegated signing. So, when you think about trying to also solve the problem of UX hurdles for onboarding creators, we really need to kind of smooth the journey to make it as minimally cumbersome as possible for people to be able to take the steps to attest to that video. So UCAN is a really interesting solution that's trying to abstract away for front-end developers and designers models that, yeah, when someone joins your app, they're kind of trustlessly giving you permission to do signing on your behalf as a creator, which is pretty cool. Eric, any other technical topics you want to call out? Or?
No, I think, yeah.
I think we got all of it.
Yeah.
How do we get back? Thank you. Cool. Next topic is decentralized broadcasting. So we didn't get into a lot of the network architecture for Livepper, but the three kind of primary actors on the Livepper network as defined by the protocol and in the white paper are delegators, transcoders, and broadcasters. And basically, orchestrators are the most important actor on the network who actually provide that video transcoding by operating a node on the Livepper network. Delegators are who kind of empower folks to run orchestrator nodes. If you don't want to run an orchestrator node, but you want to participate in the network, you can delegate your Livepper token to an orchestrator. And then, so that supply of video transcoding provided by orchestrators is actually demanded by broadcasters on the network. And because it's not trivial to actually set up a reliable supply of transcoding around the world, that took a few years. Over the last couple of years, Eric and the core team have been working on gateways to provide sources of demand for that transcoding. The Livepper API, which is kind of a hosted broadcasting node on the Livepper network today, is, Eric, I think it's fair to say pretty much the only broadcasting node at scale with real usage coming through it on the network today. So there's a huge opportunity for a much larger global network of broadcasters on the Livepper network. And so, in addition to the API, which you can use to, really easily, do live stream or video on demand, you can actually run your own broadcasting node. But where, that product isn't as developed as the API, and we'd really love the community to keep iterating with us on that. We actually have a very active orchestrator community that is really passionate about helping us advance that product. We call it Catalyst. I think it's also called Livepper in a Box. I don't know, Eric, do you want to say a little bit about what that is, where it is?
Yeah. So it's just right now it's open source. Anyone can dig in and start and boot it up and start streaming video into it. I think the interesting angle here is that you can actually use this open source software to build your own broadcasting service or your own live streaming application that uses a decentralized ecosystem of infrastructure providers, and oftentimes it's much more affordable than using an existing centralized video streaming infrastructure provider like Amazon. So just from a pricing perspective, that makes a huge difference. But also from a demand perspective, I think there's now a lot more. There's a lot of kind of untapped demand for video streaming in the Web3 ecosystem in general. So that's also another area that I think people can explore. Yeah.
And there's some pretty cool implications to think about when it comes to the relationship between these core actors on the network, the broadcasters and the orchestrators, and in terms of attesting to performance. So you think about, an orchestrator could, in theory, create conditions around which video content it actually is willing to transcode. So, that's potentially, one solution to look at for moderation challenges. Similarly, broadcasters can potentially attest to or, get attestations for the quality of transcoding happening on the network as well, which, again, isn't really possible in like a traditional cloud server environment. Anything you want to say on that? Cool. So yeah, what other Web3 on-chain video innovation ideas are there? It's really like an infinite landscape, of opportunity and like frontiers for innovation. I think we're just scratching the surface on all of these. The first area is just bundling Web3 services with a video-specific lens, thinking about creator onboarding. As we mentioned, continuing to explore on-chain native functionality. We've talked a lot about that already, and really expanding Livepper network capabilities as well. I just mentioned like thinking about attestation around performance of work on the network. Livepper is a network of GPUs where, just kind of at at the beginning of thinking about AI-based video computation or AI-based processing on the network. There's a lot kind of yet to be discovered on the Livepper network that we're excited for the community to contribute to. And you can get money to do that. We have a very generous Livepper grants program that ranges from micro grants of $2,000 if you have a really tightly scoped integration with Livepper that you want to build. We have larger grants for video disruptors who are really kind of pushing the boundaries and demonstrating what's uniquely possible in Web3 with video that's not possible outside Web2. We really love to back those most innovative use cases for on-chain video. We also have a category of grants for open network grants that are really more exploratory around network infrastructure. We don't necessarily have a cap on that because we really like to see what the community can come up with. And then we also love to do lots of partner collaborations. That's a favorite part of my job, is working with other projects in the Web3 ecosystem, whether that's to do joint hackathons or joint bounties, joint events. Livepper also sponsors other community initiatives that help do thought leadership and raise awareness and spark conversation around a lot of these topics. We're a supporter of Broadcast, which is a really cool collective of Web3 individuals and projects who are asking the question, what does the future of on-chain media look like? It's a very creator-focused community. There's a project that spun out of that called Vessel, which is looking at kind of the concept of luxury media in Web3. We launched it in New York with Seed Club and a few others. We just did a broadcast summit yesterday here at Dappcon. Zora participated in that. Lots of really cool folks at the kind of forefront of on-chain media and Web3. If you're into that and representing a project, see Superfluid here, let's chat. Come chat with me afterwards. And yeah, join the Livepper community. We're starting the Livepper Video Innovators community as kind of an alternative. I don't know if you've heard of the video dev channel that Mux runs in Web2. It's got like tens of thousands of like traditional Web2 video developers. We're really growing the video innovator community that's looking at what's possible with video in Web3. We have an exclusive Telegram group. Please join it there. And then these are the other places to find us. All the other ways we know and love: Discord, Twitter, website. Thank you so much. Thanks for everyone who's going to watch this on a recording later also. Thanks. Thanks. Thanks, guys. Oh wait, did you want to show you can for a minute? You sure?
Just say you can.
Okay. Any questions? Sorry. Yeah. I was gonna clue up, but I forgot we're supposed to take questions.
Hello. Hey, hi. I have a quick question regarding IPFS. You demonstrated something that you can push to IPFS. Does it mean that the user needs to have their own IPFS gateway, or subscription to whatever Pinata or something else? Or is it within the software?
Yeah, with Livepper, it comes with the IPFS integration. So if you already have an IPFS account, either Pinata, Web3 storage, or whatever it is, it's compatible. You can just use that. You can import video from IPFS into Livepper so that you can leverage Livepper's transcoding and scalable streaming to deliver to a global audience. But if you want to upload into Livepper that then export into IPFS, you can do that as well. And when you're exporting to IPFS, you don't need to have a separate account.
Okay, cool, thanks. And the second question is, you mentioned that you can have some read access control over the files, but if they are on IPFS, then it's on IPFS. So I don't understand how we can have both. So.
Yeah, so for that to work, people usually encrypt the video first.
Okay.
So that's stored on IPFS, encrypted, and then imported into Livepper in encrypted format. And there's a way to share the encryption key to only Livepper to then decrypt.
Yeah. Okay, super, makes sense. Thanks.
Cool. cool. I'm curious, like, what project, I know Superfluid, what other projects are folks representing, or like, what's your interest in this topic?
Hey, hi again. So I work at Luxo. We build stuff for creator economy, and
Oh, nice.
yeah, I think Louis was in touch with you, and yeah, just came by to see how we could collaborate. So yeah.
Very cool. Love Luxo. Awesome. Okay.
Cool.
There's no other questions. Thank you for coming. We'll wrap it up. Thanks.
Yeah, thanks everyone.
This also includes all metadata and also execution. So you can envision this as a middle layer to interact with all DeFi primitives and a convenience tool instead of building everything yourself. We have ranging from DEXs, lending protocols, vault protocols, yield protocols, leverage, and so forth. Should be made aware, all of this can be batched together into one transaction, and today we'll be building on top of Safe. So, yeah, with metadata, you can get APY, TVL, pools, logos, URLs, and so forth. And we have a dedicated Telegram chat for this workshop. So if you don't want to ask for assistance in person, you can also simply just ask inside of this group. All of the resources that are about to be shared will also be inside of this Telegram group. Just to reiterate the tools that we'll be using today, BotFather, which is Telegram's bot framework where you will generate an API key, Grammy, which is a simple SDK for interacting with the Telegram bot, Tenderly for transaction simulations, Safe for the smart account and transaction bundling, and finally, the Enso API for the DeFi execution. At the end of this, we will have a nearly fully production-grade product that you could release in prod that's fully non-custodial for DeFi interactions. The repo itself has all of the steps of kind of challenges. We recommend to start off with the metadata service so you can get used to the API itself, and then finally go to the executional side. Whenever you use this repository, we've already put in a Tenderly fork URL, so you don't need to worry about putting any private keys, any addresses to from addresses, and today we'll go directly from ETH to all the other positions. And what you only need to care about really is the enso.ts file, nothing else. Here's the resources, so the repository itself, the Swagger of our API, and also our docs. I'll leave this on the screen here, and we're here to help if you've got any questions. And at the end, since I'll just show it, this is where you will kind of get to. So you will be able to, let me show you, list all the projects that are available, 1 second, through Enso, all of the pools and positions that are available to this protocol, and all the APY related to this individual pool. You're also able to do individual routes into one DeFi position, and then you can also do more complex of bundling many routes into a DeFi protocol, different DeFi protocols. There's some extra challenges at the end of this repo, which are a bit more complex, and if people get to it, good job, where you're able to do lending, borrowing, yield, vaults, hedging your positions all within one transaction. So if you get to that stage, definitely call us over and we can assist. So yeah, leave it over to you. Here's the repo. Just clone it, set it up, and let us know if you need any help. Thanks. Your first step will be starting to communicate with BotFather, and then he'll generate an API key inside of the repo, convert from an environment example to real environment, and then paste the API key. It'll get up and running. Cool. Has anyone got the route endpoint done so far? Yeah, cool. Has anyone got the listing of projects? No? Okay. Anyone got the bundle of routes completed? Okay, cool. Everyone's done a great job. Let us know if you need any help. Cool. So thank you everyone for coming. We've got 5 minutes left. I hope you all learned something today about DeFi actions with Safe, with Tenderly, and how you can essentially build a full DeFi Telegram bot within a couple of hours. If you do have feedback on how it was in the workshop, also how to use our API, please give us feedback. So we've got a QR code here. Anything good or bad, whatever it may be. We know ourselves that some of the endpoints are saying standards, projects, and so forth. That's something we learned today. So if there is anything you would like to help us on, feel free to share. And we'll be at the booth for the remainder of the conference, and hopefully we can see all of you at the after party today. Thank you for coming.
All right. Thank you all for showing up here on a somewhat rainy afternoon on the last day of Dappcon. My name is Sebastian. I'm founder of HOPR, and I'm very happy to talk to you about a topic that's kind of dear to me and I think very much overlooked in the wider Ethereum ecosystem. So, is there anyone in the room who has an Ethereum wallet? Hands up, please. I see a few hands. That's good. Cool. So, I aim at making this a more interactive workshop. So, yeah, we're going to play through some stuff. And my objective here is to first make you aware of what the issue is with wallet privacy on a layer that's not so much talked about. Secondly, briefly talk about what we do at HOPR. And thirdly, present a latest project that we're just launching now to fix that. And yeah, that's what we'll be talking about in the next 45 minutes or so. If there's any questions, please interrupt me anytime and ask. If there's any technical issues, my colleague Felix here in the front, also in a yellow t-shirt, is very happy to help you throughout the workshop. So after we've seen that there's some people in the room who do have an Ethereum wallet, that's great. I would like to make you think about, do you have something to hide? Right? And you might say, no, I have nothing to hide, right? But this is the wrong question when we think about privacy. Right? So privacy is really about getting these fundamental human rights back into the digital space. That's what this is about for me. For me, this is not about, oh, I'm not an illegal guy, I didn't trade on Silk Road. Most people who entered crypto early did trade on Silk Road, and I don't judge any of that. It is about giving you the human rights that we have in the real world and try to bring as much as possible of that to the digital world. Because without that, this digital great new world that we're building for us and for the generations after us who are, building amazing things is just corrupt. That is, to me, what the Web3 should be all about. Now, as we enter the Ethereum ecosystem with our wallet, there is, your wallet, which is kind of naive. It doesn't know what's going on in the world. In fact, your wallet is a pretty dumb piece of software. It can typically store a private key, more or less secure, can make transactions, but that's pretty much it. Specifically, your wallet does not know, for example, your balance. It needs help. And the help that your wallet gets is coming through a so-called RPC provider. RPC stands for remote procedure calls, and it's what your wallet does in order to get some information, such as what is my ETH balance, what's my ERC20 token balance, what is the current gas price, and stuff like that. So the first thing that we're going to do is we look at, there's a bunch of people here who I know are familiar with all of that. But we will look at that in a practical setting because I promise you there's going to be some things that even the ones who are more familiar with Ethereum for many years already will find surprising. So the first thing that we're going to look at is DERP. DERP stands for Dumb Ethereum RPC Provider. And basically, all that DERP does is it serves information to your wallet, and it echoes it back to you. We made a nice website, which makes it a bit more interactive and tangible, because otherwise the data which is made available to these central providers, which are, seeing and helping out your wallet with all the information that it needs, it's something abstract, right? Metadata is something, I care about my IP address. Well, bad news, it's much more than your IP address. So the first thing that I would like you to do for the ones who want to play along is navigate to DERP, that's derp.hoprnet.org, HOPRnet.org. You can do this on a mobile. It is a bit more cumbersome on a mobile. So if you do have a laptop, I would encourage you to do it on a laptop, just because you can have multiple windows at one instance. Now, what this thing is again, you can add an RPC provider to your wallet and it echoes it back to the website. We call it Dumb Ethereum RPC Provider because we don't actually do anything with it. In fact, how it works is, by the way, you'll also find the code for all of this as everything we do on our GitHub. So if you want to mess around with this for other purposes, please feel free to do so. So what this does is actually we have a server which just proxies requests, right? It takes your request, it sends it to some other provider that we have configured, and it also like echoes it back to your website. We don't store that information. Of course, you have to trust me, right? It could be that we're running different code there, you know, so don't assume this is private. Just as with any other RPC provider, do not assume this thing is private. Do not assume that we are good guys. And yeah, then it's mirroring it back to the same IP. I just realized we are all connected to the same IP address. I'm pretty curious how this will work. Let's see. So I'm going to demo it to make this, at least for me, a little bit quirky. I'm going to be connected to my hotspot. The second thing, if there are some quirks here with everybody having the same public IP, do not do that with a wallet that you don't want everybody else in the room here to know. Yeah? So I'm going to talk about privacy, but in its demonstration purpose, you might leak information about you that you don't want to leak. If you don't want to do that, don't go ahead here. Do it from your home, from an isolated network, and so on. So I'm on the DERP website. Again, it's derp.hoprnet.org. And I am using MetaMask. This does work with most other Ethereum wallets that I'm familiar with, just to make it easier to follow along, because I know MetaMask is not the prettiest wallet, but it's the most popular one. I'm going to demo it for MetaMask. So I'm going to hit that setup button, and you see, can you actually see that? Let me make that a bit bigger. So you can use DERP on various chains. And again, all that we're doing here is we are adding this endpoint to our wallet now, and what our server in the background does, it just proxies it back to some other provider. So I am going to be, since we're in Berlin, I'm obviously going to do that on Gnosis chain. So I have my MetaMask unlocked here. By the way, you saw that little glitch when it took like half a second to load, like this little MetaMask moment. We will look in a second what that MetaMask moment actually is. Like, why does that happen?
So you just give that URL again for DERP.
Yes, it's derp.hoprnet.org, HOPRNET.org, derp.hoprnet.org. Yeah, so basically I have my MetaMask, I have it unlocked. By the way, there was a new version of MetaMask coming out last night, but it should work with either. They now have snaps integrated, which is awesome. So I'm going to hit switch, and now you'll see that it adds this endpoint to my MetaMask. It asks me, do I want that? And in my case, yes, I do want that. So it just asked me to confirm that. Again, like what's the worst case trust assumption at this point? Like MetaMask asked you about something, hey, watch out. Like at this moment, you all should be, do I trust these guys? So the worst case trust assumption here is that this provider sees absolutely everything that your wallet does, okay? Just for your info. I'm going to prove it, and I'm going to switch the network from Ethereum mainnet to DERP Gnosis chain. Switch network. And I'm going to scroll down here, and there's a bunch of interesting things going on here. So first of all, it shows me I'm in Switzerland. That's weird, right? This is my IP address. Why is that? Because I'm connected to my hotspot. Yes, I doxed myself as having a Swiss carrier. And you see already some addresses here. You see chain ID, and you see that it made 7 calls. Like, okay, interesting, right? So the RPC provider was already being informed of my Ethereum addresses. Anybody got a clue why that is? I just connected it, and the RPC provider already knows my Ethereum address. I didn't make any transactions. Why? Query my balance, exactly. So in the table down here, we see the actual requests that are being made. And what we see is that, let me try to see the ordering of that one. So the latest one is on top. So basically what it did is an ETH get balance. So for the ones who are not familiar with Ethereum RPC calls, it's basically a server, and on the server we're calling a function to say get me my balance. And the function that's called get me my balance is called ETH get balance. That's the endpoint. That's kind of obvious, right? And in order to find out my balance, it needs to know my Ethereum address, and that is this one here. Now, what is maybe a little bit less obvious is that there are additional so-called header fields in these requests, which reveal already something about me, right? So this is all metadata information, which, if you actually think about it, the provider has no point in knowing, right? There's absolutely no reason why a provider would need to know that I'm on some, Mozilla-based thing on a Linux, and a bunch of other information. So that's a bit weird. It's oversharing. And the more important thing I find is up here, my IP address, right? So the provider at this point knows about my IP address. And at this point, I would like to make a little pause because I sometimes get this feedback of like, okay, Sebastian, surprising. The RPC provider knows my IP address. Tell me something new. And I'm saying, well, that's private information that is not necessarily shared with them. Okay, fine. I'm not so concerned about sharing my IP address. What are you going to do about that? What I am concerned about is linkability. Who here has more than one Ethereum address? Okay, 1 or 2 people, good. Now, maybe some of us have an ENS domain that is linked to the name, like I have like Buergel, which is my handle that I use all over the place. I have a POAP address, right? Patricio running around here. Everybody that runs into Patricio gets a POAP if they want it or not. You collect these things that are tied to your face, to your real-world identity. And many of us have, some savings in crypto that do not necessarily need to be tied together. You should have the right to separate these two. Now, this provider here can link them. This provider now sees that the exact same IP address queried, within very short time. Actually, if you look at the timestamps here, it's kind of funny. So within the same millisecond, you get hit from the same IP address with, an ETH get balance request from 2 different addresses. Well, probably that person is controlling these addresses or was sitting in the same room and so on. So yeah, that is something that I find much more concerning, right? So that is something that I find much more concerning than just sharing my IP address is linkability. The second answer that I sometimes get is, well, you're a pleb, you use a centralized provider. I'm a smart boy, I run my own Ethereum node, I run my DApp node. That's cool, but let's think about what that means. You use your DApp node, and these read requests to check your balance and so on, they all go to your node, and your node doesn't inform anybody else. That's okay. But when you send a transaction, this transaction is being sent through your DApp node from home. That doesn't originate any other type of addresses. So it is pretty trivial for other participants in the network to find out where that transaction originated from. So your DApp node, your own Ethereum node, is in fact helping you for reading. It keeps reads private because it isn't shared with anyone, but it does not keep writes private, right? Writing to the blockchain is not kept private because your DApp node or whatever you use is synonymous with your identity. It's exclusive. In other words, as we sometimes say, privacy loves company, right? So you want to share this thing. But then again, you have a provider which other people need to trust. What do? I also sometimes get the answer, well, I use a VPN. Okay, let's look into that. You're a smart person who uses a VPN. A VPN is great because that VPN that RPC provider doesn't see where you live. They don't see your IP address. But I'm not really concerned about that because this information of my IP address is not really concerning. I'm concerned about linkability. So in essence, you're changing one centralized provider, which is like Infura, Alchemy, or some of these other RPC providers, with another one that's called a VPN provider. I have no reason to trust one more than the other. It's a centralized trust assumption that this person and all the people in that company don't violate that trust. So let's think about how that actually is in terms of privacy under this threat model of I'm concerned about linkability. Use a VPN provider, okay, like NordVPN, something, hopefully something, more legit. This VPN provider has a bunch of servers. So your anonymity set, so the number of people who could be you, is the number of people who use your VPN provider on that very server that you're connected to at that exact time with the same metadata information that your wallet produces. I can guarantee you, whatever VPN provider you're using, you are alone. Your anonymity set is going to be 1. So in terms of linkability of addresses, that's not really going to help you. That's not good. So we're going to fix that, but first of all, I just want to show a few more things that I find kind of interesting when looking at this thing here. So first of all, like for you all here in the room, do you see everybody's request actually? Yes? You see like a whole lot of other addresses which are not yours? Yes or no? You just see yours? Sorry? There are more. Cool. Okay. So, welcome to the club of, Ethereum addresses in this room. Congratulations, you doxed each other. So, yeah, let's look at what is actually going on as you interact with a dApp out there if you do anything, right? Because it gets worse with regards to privacy. So again, for the ones who didn't manage to set it up at first, you just go to derp.hoprnet.org, derp.hoprnet.org. You hit the setup button and you add this network to your MetaMask. Now, what happens actually so far is kind of, not surprising. MetaMask is querying the block number, basically asking, hey, provider, what's the time right now in terms of, block number. We just see the request, we don't see the response, because the response is kind of, it doesn't matter, you can always kind of reconstruct it from the request. So I didn't do anything, so all the time while I was talking, my MetaMask seems to be every 30 seconds to be querying the current block number. Fair enough. So let's do something. I'm going to send myself some ETH. By the way, if you want to do something cheap, I encourage you that you do that in Gnosis chain. There is a faucet called gnosisfaucet. Felix, what is it? gnosisfaucet.com.
You just look for Gnosis Faucet.
Yeah, gnosisfaucet.com. You can request like a fraction of an extra, which is kind of cool to just toy around with it. Now, the first thing that I'm going to do is I will, what am I going to do? Is I'm actually going to use sushi. Like sushi is kind of like, yeah, it's kind of interesting to look at. So I am going to keep my browser windows next to each other so we can follow the new requests as they come in as I'm doing stuff here. So far, MetaMask is just querying the block number. I'm going to, okay, that's a bit lame because I'm already connected here. I'm going to disconnect. I'm going to reconnect my MetaMask. And I'm going to start a swap. So SushiSwap already knows that I have 0.3 XDAI here. And I'm going to switch, 1 cent for GNO. It's going to be a tiny amount of GNO that I'm going to get out of this one. Okay, I'm willing to swap for it, right? This is just front-end interactions. Now, something interesting starts happening here. It does an ETH get code, right? What is ETH get code? Well, ETH get code is just a request to get the bytecode in the EVM at that address, which is probably the sushi router. Let's quickly check it out. Gnosis scan.io. It's the Gnosis blockchain explorer. I'm just going to copy paste the address. I'm going to look at the contract, and indeed it's the root processor number 3. Okay. We're looking at this from a privacy angle here. So what does that leak about you? That leaks to the RPC provider that you're about to use SushiSwap, right? Okay, whatever. It does an ETH call. Okay, interesting. Well, it's the same address, and now we're calling a function. We're reading, right? This is a read on a smart contract. So what are we reading here? So if you're new to Ethereum, like you might be interested to hear that the first 4 bytes of this thing, so the first like 10 characters, encode the function of what we're calling there. So I'm going to copy paste the first 2, 4, 8 bytes of this. And there's a very cool website called 4bytes.directory. 4byte directory. That allows you to do a reverse lookup of this function signature. And yeah, this one is a like since just first 4 bytes, there's some overrides. So the first one I think is just some bullshit thing where somebody found a hash collision. But the second one is most likely what I'm actually going to call, which is supports interface, right? So it's basically trying to find out like if the smart contract supports something. I don't know exactly what it does. So another ETH call, a bunches of ETH call, and a fee history, right? So now somebody's querying kind of what is the fee history, so how expensive is it going to be if I make a transaction? And now something very interesting follows, ETH estimate gas. So if you look at this ETH estimate gas, that's basically asking, hey, tell me how much gas do I have to spend for this transaction? And that's basically just so that your wallet knows how much to send along. Again, very boring, I know most of you know it, but think about it from a privacy perspective. What does that mean? We might trade, you know, $1 million worth of stuff. What happens when you trade $1 million on a kind of naive AMM? You know, there's front running, back running, all this fun stuff called MEV. Cool. Now you are sharing with a centralized provider what you're about to do. This is not a transaction. This is something that you're pretty certainly going to do because you just hit the button what you want to do. So you see in this transaction, like this from addresses me, you send something to the sushi router, you see, you know, exactly how many XDAI I'm going to send along, and a bunch of other things. This is like route information and the recipient address, and I don't know why my address is in there twice, actually. So you disclose everything, what you're about to do, before you have even signed it. Now, congratulations. I can tell you what I'm going to do with that information if I'm an MEV hunter. Yeah? So, again, if this is nothing new, this is all cool, but let's think about it for a second, the direction in which Ethereum moves. Ethereum moves in the direction of decentralization. I'm all up for decentralization. I want decentralization of power. I want to see decentralization of infrastructure. But this information is currently going to, you know, if you're on mainnet, chances are it goes to, you know, Joe's basement, and we all trust him. Maybe that's fine. Let's fast forward. You know, there's people working on decentralized RPCs, which again, I want to see decentralized RPCs. But there's now a random lady on the internet or a random dude on the internet that you trust with this information. Is that going to end well? I don't think so. So in order to decentralize infrastructure, we need privacy building blocks in order to use that safely. So that's what this is about, and that's what I want to think about when I see these things. So you disclose something that is not signed yet, so it could be bullshit, but chances are this is real, right? If I observe you for a long time, I'm going to find out patterns, and I'm going to be able to front run everybody else because I know what you're going to sign in a minute from now. So that's why I find it kind of interesting to look at these things. Okay, I was talking for a long while, so it was querying my balances, getting block numbers and whatnot. Now, let's actually go ahead and sign this transaction. Cool. Confirm. I signed it. We see an ETH send raw transaction. ETH send raw transaction takes the signed transaction, broadcasts it to the network. That's the thing that now, you know, if this was mainnet, where a bunch of searchers would jump on this thing and go like, you know, goblin mode on that one, try to find out how they can screw me. So, and if you compare these two, requests, it's a bit longer to scroll, but you might remember it. They look quite similar. The only thing that's different is the signature. The signature is the only thing that's different in the second one compared to the first one. And yeah, so there's an opportunity to front run the front runners. If you're an RPC provider, there's a lot of other information that you leak even before you signed that actual transaction. Good. Okay, so that was basically something that can go wrong. I want to show one extra fun thing. I told you like this little MetaMask effect when you like click the thing the first time and it was stalling for a while. I promised you we're going to look at that, you know, what actually happens there. In order to look at that, I'm going to close my browser window. It's going to be probably a bit more messy for all of you who share the same anonymity set there. What I'm going to do is I will actually, by the way, shout out here to CubesOS. I found a wonderful privacy respecting and safe operating system. I'm going to open a separate VM here just to keep things super separate. And I'm going to open this website again just to, you know, visualize that I'm not cheating. So currently my MetaMask is closed. MetaMask is not running. That's why it doesn't show any requests. Yeah. So, oh, interesting. You know, something somewhere is creating an ETH block number. Now that's weird. Because I had this one open. Okay, well, fail. Cool, reload this. Now, actually, everything else is closed. So I'm going to open my demo VM again. I'm going to open my Brave again. Okay, there's a bunch of requests. Yeah. Interesting, right? My MetaMask is locked. Yeah, my MetaMask is locked, and yet it already like made a bunch of requests to the RPC provider I'm connected to. Luckily, in this example, I didn't, you know, it didn't leak my address yet, but like it made requests to an RPC provider which revealed private information about me, such as my operating system, my IP, the browser version that I'm using, the wallet version that I'm using, and so on before it's unlocked. So, and the next thing that you see is, as I scroll down here on the right, let me minimize that one. Okay, Sushi wants to connect to it. Close Sushi. If I hit this MetaMask, you see this request going out here? Like, so MetaMask is making a request. It seems to be like synchronously waiting for the request to come back, and then it loads the UI. So like that stuff that you see when you kind of look at the requests in parallel. That's why we have this MetaMask second when we load. I don't know why they do it that way, but we see it. Good, okay, I don't want to dive any deeper into the issue of what your wallet leaks about you. I think it should be evidently clear that an RPC provider is a centralized point of failure which we trust with a lot of metadata that can be used against us as individuals which are interacting with the Web3. I don't care if you're doing, you know, $1 million trades on Uniswap and you can get front run by some searchers, or if you're sniping an NFT where somebody's, you know, trying to come first, if you're interacting on Web3 social where people kind of can see what you do and who you interact with even before it happens, you're being watched all the time, and it's something that needs to be fixed. There's a lot of people working on on-chain privacy, and I really hope that happens, but on-chain privacy isn't enough. We need transport privacy to protect this, sometimes they call it Achilles heel of Ethereum, because, yeah, if we have on-chain privacy and your IP address becomes your primary identifier, that doesn't help us much. So, luckily, somebody's working on it. Yes, it's us. We are at HOPR. And let's briefly talk about what we do at HOPR. Let me open that up real quick. So basically, HOPR is a mixnet. What is a mixnet? A mixnet is a network for relaying data. So I can send data to someone here in the room by sending a data packet to you, who relays it to the next one, who sends it to the final recipient. So I'm forwarding data packets, so the recipient of these data just sees the last, sometimes also called exit node. They don't see the previous relayer or the previous relayer before that, or even the sender. It's obfuscating where data came from and where it goes to. And again, there's some people in the room here who have heard about VPNs, we talked about it, or Tor, and indeed that is something that sounds very similar to Tor. You have this multi-hop relaying of data that is very similar to Tor. But there is 3 important differences to Tor. The first one is we do what is called packet mixing. So as visualized there, data packets are coming into a mix node. This mix node is caching data packets for a short amount of time, transforming them so they look different and indistinguishable when they come out, and sending them out in a different order. And that is how even a super strong adversary, let's say your internet service provider, who sees every packet that goes into your router and every packet that comes out of your router, cannot link incoming and outgoing traffic. That's something that you don't have in Tor, because Tor takes packets and sends them on, and you can kind of tag them. A mixnet, therefore, has stronger privacy assumptions than Tor. Specifically, the trust assumption of a mixnet is that only one node along this path is honest. If you have one honestly mixing node along your route of multiple hops, then you're fine. Why? Because this mixing and tumbling of data cannot be linked. Cool. So the second one is that this is, of course, a decentralized network. So it's a bunch of relayers in this network. And the third one is that people can make money by doing so. So if you relay data for others, you earn HOPR tokens. So the people who operate these nodes, they stake HOPR tokens in order for you to use that and gain privacy. That's the HOPR network, and you can use it for general purpose application. You can build a private chat app on top of it. And by the way, we've done that a while ago. You can use it for a private IoT app. Or, coming back to our wallet problem, we can try to solve that wallet problem. That's what I'm going to get into now. And you're going to be the first ones outside of the HOPR team who are actually testing that. So please forgive me if something fucks up. This is a product that's live since 2 days, which is running on top of infrastructure that is live since 7 days. So somebody is laughing. Yeah, please laugh when it fails. So yeah, what is RPCH? RPCH is, as we call it, a private RPC provider. Now, since we've been diving a little bit deeper into the whole thing, like, this is actually not true, but it's catchy and people understand what I'm talking about when I say it. So for this audience, RPCH is privacy middleware that sits between your wallet and the RPC provider and connects, or actually disconnects these two by the HOPR mixnet. So RPCH stands for RPC over HOPR. So we change the underlying transport infrastructure. When you edit a network to a MetaMask, you have this drop down. Again, it takes 1.5 seconds, obviously. You have this drop down here. These entries, let me actually unlock it and we can look at the entries. They all begin with HTTPS, right? So HTTP is using existing internet infrastructure, which is not privacy respecting. So add network. So all these networks basically begin in the RPC URL, begin with HTTPS, which is secure, right? It's end-to-end encrypted, but it's not private, in the sense that third parties can see exactly who you're pinging there. So that's what we want to fix. And therefore, we cannot use just another entry because all the entries on this list use HTTPS, which is not metadata private. So we need to do something else. So that's a bit tricky, right? Because HOPR is, as I said, live since in that version since 7 days. For some unfortunate reason, Brave has not integrated HOPR yet in these 7 days. Chances are that's not going to happen tomorrow, so we need to find a solution. And what we actually do, what I'm going to demo and we can do together here, is that we add a executable that's running on your computer. In what I'm going to demo here is based on Docker. So the ones here who have Docker running, yeah, that's a Docker container that we'll install that is running a local instance to which you can connect your wallet, which is then taking these requests that reveal so much about you, breaks it up into indistinguishable looking packets that we've seen in a beautiful animation before, sends it through this HOPR network, and then sends it to an RPC provider. And remember when I said I was cheating a little bit when I said that HOPR is a private RPC provider? Well, you can send it to any of the centralized providers that we have today. But they will not see your IP address and they will not see that it came from you, right? They just see the exit node from which it was coming. And that looks kind of indistinguishable. It's used by a bunch of people, and therefore you have stronger privacy assumptions than even a VPN. So let's look into how that actually works. So I would like you to go, by the way, is there questions this far? Yes?
Will it also help with the time correlation that could be made? Because even if they don't know who you are or where it came from, if they see 2 requests that come in the same millisecond for 2 different others, they can
There's not much you can do. Exactly. And also, if you have additional information such as header information, you're screwed. Basically, if the application is screwing you, there's nothing we can do. We can help you to get better than that if the application tries to, do a reasonable job. In a previous version, MetaMask had actually these batch requests, which in a single request was sending out all the addresses. So that's even more trivial. We got one step better now, half a year later. I think, if we're all bitching a bit more, maybe they just do individual requests and, and separating that. But you're absolutely right. If there's application layer data or metadata that is being leaked, you can fix that on the transport side. Other questions?
Why did you choose to like mix and add latency to requests rather than just obfuscate with a bunch of crap?
Yeah, so why did we choose to like fix latency instead of adding a bunch of crap? That's actually a good question, and in fact, we are doing both. So this adding a bunch of crap is translated in kind of academic terms. We call that cover traffic, right? So cover traffic is background noise. And if, you can imagine that if you're standing in a football stadium and you're shouting, I know it's you. If there's 50,000 other people who are shouting around you, I can't hear it you. So that is what's going on. We do that general purpose, again, on the transport layer, not with the RPC data. But in theory, what you could do is you could run some, something locally, a service that is, dispersing a bunch of random RPC requests from like Vitalik.eth and whatnot, right? Yeah, you can totally do that. Good. Okay, so let's jump into RPC. So I would like to ask you to enter rpch.net, again, which stands for RPC over HOPR. And RPC over HOPR is, again, this additional layer, and we want to use it now. So in order to get access, it's a free alpha. Again, you're the first ones who actually use this thing. I would like you to hit the access button at the top right. Fonts are looking almost right. And you hit the dgen package. Is a dgen package because the only way to access that is unfortunately Docker. I know normal people are not going to use Docker. I hope some of you are. So in order to get started, because it's for you, we do not ask you to log in with Google. We ask you to log in with Ethereum. So I'm going to connect it to my MetaMask. MetaMask is going to ask me to sign some stuff. Whenever you sign something, please do check what you sign. When somebody asks you to sign random looking hex strings, please don't do it. Like there's standards that look better than this, which is this one here. So you say, sign in with Ethereum to RPCH dgen, the URL, chain ID, and so on. Looking good. Okay, please do not sign random hex strings. Lots of accidents happen there. Cool, I'm logged in. And that is basically to just enforce that, there's not people who just completely hammer us and overrun the network with a ton of requests, and we could just say, okay, for that client secret, we will just on the entry node side reject these requests. So this demo expects that you have Docker installed. If you do not have Docker installed, we have docs here which show you how to do that. I will not go through the Docker installation because, especially if you're on Windows, it's like a bit painful. If you're on Linux, congratulations. If you're on Mac, it's so-so. So you can basically just copy paste that one into your command line interface, into my terminal. I'm just gonna copy that one in. And what this does is let's take a very quick look at what this does here. It starts a Docker container, which is a translator between your wallet that you locally run and the HOPR network. Now, this thing is in its first version also not very smart. It doesn't really know the HOPR network. It needs to get introduced. So there's a central point of trust and failure, which is called a discovery platform. The discovery platform is basically your matchmaker. In this decentralized network, you're invited to the party, but you need to get to know other people. That's your matchmaker. If you don't like that, well, you've got to run a HOPR node. Again, as a first version, I think it's still much more private than any VPN that you might have. So I think it's fair enough right now, but I want you to be aware of what is the trust assumptions of this network. So yeah, it pulls this thing and it exposes a locally running RPC server on port 45750. It's a little puzzle to figure out what the number stands for. I will not reveal it here. And that's what we will add to our MetaMask or whatever other wallet you have running locally. So I'm going to run that. I have already pulled the image. So the first time you run it, it takes a bit longer because it's pulling the image. I already have that. And once your RPCH server, that's how we call it, this Docker container started, you see basically this message here. So some status time, RPC server started on. And yeah, there's some additional flags that I'll talk about later. Cool. So now this thing is running here. And I'll keep this running in the background. And there's a button down here, add Gnosis chain over RPCH. Okay, sorry. For accessing for the first time, I didn't mention that. You need a code to actually pass this thing. Thank you. It's called free privacy in capital letters. Free privacy is the access code. Thank you, Felix, for that. I forgot to mention that because I was already logged in. So to get there, you log in with Ethereum. And in order to log in, you need the code free privacy. Very important. Please let me know if there's any issues. We had already a service crashing or whatnot. No? System's still alive. Cool. Yeah. If anybody managed to get that Docker container up and running, please feel free to show your hand up. Anybody get that far? Still loading. I'll give it a minute for you to load the images. So again, this is locally running. It's going to do this translation from taking the RPC requests, sending it through this mixnet, on the other side, when the response comes back, doing the same thing, taking requests, gluing them back together again. And therefore, for your wallet, this is transparent, right? So your wallet does not need to understand HOPR. The wallet does not need to understand the mixnet. Now, how we cheat it here, basically, is you have to have this locally running container, this local container running. That's basically how we cheat it, right? Of course, the mid to long-term roadmap for us is we want to get that one integrated into wallets. So if you're working on a wallet, please come to us. We'd love to talk to you. If you're running on a, like if you're working on a web app that has like an integrated wallet or something, would be super happy to make it work like in like dApps directly as well. It's possible. We have an SDK. Basically, this Docker container is just running this SDK, instantiating it, and running it in a standalone fashion. But you can totally kind of, as a drop-in replacement for Web3.js or Ethers.js, for example, add to a wallet like that. So that's our goal, to make it much easier for normal world users and still offer them privacy that they deserve in the digital world. Yeah, okay. Anybody running the Docker container by now? Loading?
Slow Wi-Fi.
Slow Wi-Fi. Okay, cool. Good. I'm going to show you how it works on my side then.
An error connecting to the custom network.
We'll get there. That means your Docker container is already up and running? If so, the last line that you should see when it's up and running is this RPC server verbis RPC server started on. So this line means it started. If you do not see that, it means it's still like loading and doing a bunch of things. So if you connect this network, it won't work, right? Because the thing is not up and running. So we try to make that easy for you. So we have this this button here for Gnosis chain over RPCH. I'm gonna hit that button. Oh, damn it. Sorry, I had a cached version, so I need to sign in again. So the ones we need this passcode is free privacy, all capital letters, FREE, and you know how to write privacy, I hope. I'm going to add that to my MetaMask. So you just hit the button. If that doesn't work, if you're running a different wallet, you can find all the information in the docs. So you find this information in the docs. And now if we look again, who do we add here? So it's not some centralized server, it's localhost on port 45750. And the interesting thing here is we're passing it this provider flag. So it's a URL parameter. And that's how you can use derp, that's how you can use RPCH with any EVM chain. So if you want to run this thing on like whatever DGen L2 you want to, you can do that. As long as it's EVM compatible with the RPC standard, you can use it with any L1, L2, L3, whatever that you might like. You just need to adjust the URL parameter and pass it the RPC provider that actually serves this request coming from the exit node. So worst case assumption here, just briefly thinking about it, what does it mean? This exit node provider, the last one who translates this HOPR into RPC call and responds back, They will see all your requests, but they do not see where it came from, right? So we have a separation of data, which is unfortunately not private. Many smart people working on that. I hope they succeed. From the metadata, like your IP address and your identity. So we separate these two, right? So it's important to realize that. Cool, so I'm gonna add that, and the rest is just like the normal Gnosis chain. Approve. Good, so I approved the network. I'm gonna switch the network. And similar things, just not as prettily rendered as before, pops up here. So you see requests that are being routed through my locally running translator service from RPC request to HOPR. So you see that this one was, let's see what was going on here, an ETH balance request, right? So my MetaMask is obviously doing this exact same thing as before. It routes requests and gets responses on the way back. And just to demo it, I'm going to go again on sushi.com, and I'm going to swap the same thing that I did before. I'm going to swap it back. So where is, it's already connected. Cool, so I'm going to swap it back, and we keep looking at the requests that pop up here. I purchased some GNO. Now I'm going to swap these GNO back. Proof GNO, we see a bunch of things are going on. Again, same thing that you saw before in kind of pretty rendering on the Derp website is now going through here, but now it's being made private. So I'm going to approve it. You see this big request here, which was probably an ETH estimate gas, right? This huge ass thing here. Wow. Okay, no idea what that was. Looks like a huge request. Okay, approve. Nice. Transaction failed. Unable to process. Internal JSON RPC. So probably I was waiting for too long. Let's try again. So I'm gonna approve it again. Approve. Transaction failed. Okay, so I'm gonna hit some error here. No idea what's going on. But in essence, we see these requests being routed in the exact same fashion as before, kind of through this mixnet from your wallet to this exit node and a response on the way back. And that's what you see kind of being logged down here and coming in and out. So here, what do you receive here? ETH gas price. So that is RPCH, which uses the underlying HOPR mixnet. And again, if you're working on a wallet, working on anything that is using RPC calls, happy to talk to you and think about how to integrate that, how to make use of that, how to make the Web3 more private than it is today. If there's any questions, happy to answer that later. Otherwise, thank you so much for joining me here today.
In terms of the mixnet and communicating between peers, when you bootstrap, what networking topology or networking protocol do you use underlying, say like UDP, libp2p, these kind of things?
So HOPR is based on libp2p, so it can use any sort of underlying transport that libp2p supports. And so it's quite flexible. So currently, we recently shifted to Rust libp2p, so it's we had a JS libp2p, which was a bit painful, and now, that was quite a good transition.
And how wide is the k-anonymity set at the moment?
Very small, because currently the entry and exit node is operated by us. That's what I mentioned before, so it's very small. We have currently in the network approximately 300 nodes running. What matters though is we have this payment channel topology. So in order, I didn't really get into HOPR here because I wanted to keep the discussion at the level of this RPC provider. So your node has a customizable strategy by which it opens payment channels. You can open payment channels to everyone here, or you can say, hey, I optimized for ROI, right? I open channels to a few select candidates and optimize my return of investment.
Cool, and sorry for the HOPR specific questions.
No, go ahead.
for each subsequent RPC request, does it essentially become non-replayable? So the next message that is sent along the HOPR network, is it able to be identified as relating to a preceding message?
It is for the exit node, yes. The exit node needs to know that they belong together. So basically, the current version of HOPR is a bit like UDP, in that you send individual packages. And that's why it's a bit painful to build applications on top of it. So we basically need to build TCP-like features on top of this UDP-like protocol, which, yeah, we know there's some work left for us. So, and that's why the exit node knows they belong together. So, yeah, we have a crypto paper description in the docs where you can find the details to it.
Sure, because it would be quite nice if the, say, like ETH estimate gas was completely disconnected from, say, the ETH send raw transaction.
That is the case. So that is actually the case because every packet goes a different route, but the exit provider needs to be able to glue them back together, right? So per request you hit the same one, but then in between, like, they all go different routes.
Cool, thank you.
Thank you.
Thanks for the talk. Do you have a plan for mobile, like running a Docker container there and like consuming so much data is a problem for a lot of users? Do you have an idea how to solve that?
Yeah, so in fact, that's one of the main reasons why we are migrating to Rust is, not just performance and stability, but also to much more easily support mobile ecosystems, which so far was hard. But yes, that's absolutely the plan. In terms of bandwidth, as a user, as long as you're not actually running a HOPR node, the bandwidth utilization is not going to be crazy. It's going to be higher than before because we pad the packets all to be to the same size and so on. And obviously have header overhead. But otherwise, it's not going to be too crazy. Like in the next version, you would run kind of like a small HOPR node on your device. And then the bandwidth overhead that you have is, well, it's really up to you. So there's this annoying trilemma. It's called the anonymity trilemma, which is a trade-off between low latency, low bandwidth overhead, and strong anonymity. And like in there you can choose, and for example, if you want like pretty decent privacy and pretty low latency, you need quite some data bandwidth. But basically our objective of HOPR is to give you a choice. You as an application developer or user should be in a position where you can make trade-offs in this triangle, because it's not going to be the same for all of us.
Yeah, I'm not that concerned about the data usage while running it. I'm more concerned now with the whole setup of Docker. Because like alone there, you transfer like 500 megabytes or whatever.
Exactly, yeah. So the current version, we are not complete with our Rust migration, so it's still running in a node engine, and then unfortunately it's big. Yeah. So the memory footprint we already managed to like significantly reduce. So I think currently it's like around 60 megabytes. And like if you run it in optimized setting, but yeah, it's going to get there. It's going to be manageable.
Thank you so much.
There's no more questions. I'm also around. You find us in the yellow t-shirts. Happy to answer any questions later on. Thank you so much. Stay private.
Okay. Is it good? Do you hear me? Amazing. I don't know why you... That's better. Okay, my name is Dmitrii. I'm from GetBlock. I'm a product manager, and today I will tell you something about us and how to work with GetBlock to make your life easier. So, blockchain infrastructure. Have you ever tried to run your own node on your maybe home PC, or you have rented your any servers in some host providers? Yeah, tried? Yeah. And what is your experience? What do you think? Was it hard? How many times you cried in this process?
Can manage your machine.
Yeah, I'll tell you my story. I have a 2K euro PC. I spent a lot of money, and in my beginning of this way of the product manager, I tried to run my own node on my own PC at home. I spent about a week trying to synchronize the archive data for BNB Smart Chain, and I guess you know I'll never did it because it's not possible to do it on your home PC with just 1 week. Anyway, how we can help you? We are node provider, and we can provide you nodes and fast and easy access to this. And you are developers who just don't want to think about the situation of their node synchronizing from the beginning of the blockchain, wasting your time, days, weeks, maybe months if you're trying to synchronize full archive data of Ethereum blockchain. And yeah, that's easy way to do this. What are the challenges when you're operating your own node? As I mentioned, it's very long time of doing it. And every node can give you a lot of pain in your ass, because sometimes it's falling down because of the workload, sometimes it just can't stop, or you can do something wrong with methods you use and just stop this node and crash whole database. So that's one of the reasons why it's better to use blockchain provider. You are developers, you are doing dApps, we are node provider, we can help each other. As you know, as we know, in the beginning of this way, you would like to spend as much less money as possible. Maybe it's free, and we can offer this solution for you because we have free plan of using our nodes. It's 40K per day free on our platform for 50 plus blockchains. And yeah, what is the remote procedure call? Because we are RPC node provider, RPC is a remote procedure call. That's the fast and easy way to connect you and the server. The server in this case is the node, and you as a client is your dApp. So you run your own dApp, we have server with node, fast and easy connection, and even free or cheap way to do this. As I mentioned, we provide 50 plus blockchains on our site, on our platform, and it's all can be tried for free. And most of these blockchains has mainnet and testnet either. And yeah, some of the use cases of our experience, of our life. We have a lot of clients who develop dApps, for instance, wallets, like Tangem. I guess some of you could listen to this name. We have big audits companies who has to analyze a lot of data from the blockchain. I mean, like they have full archived data block nodes with blockchain, and they send every day a lot of ETH call, for example, methods. We have exchange, right, not companies, dApps who trying to change and build bridges between blockchains, and of course trading bots who need to know as fast as they appears transaction in the blockchain to analyze data and get these balances of the wallets or something to react best way and earn money. So, as a conclusion of this topic, I would say we help you earn money and save your own money. Why use RPC provider as a GetBlock? So we have great support. We have 24 hours and 7 days every week, every month, even New Year's support. We will help you with any of your issues. We can help you with your code even. We can help you with any problem you faced in your life, in your dApp developing life. We guaranteed you high availability, and of course we provide you 50 plus blockchains on our site with no problem. If you're talking about our ecosystem, we have 3 main products. The first one is shared nodes, when multiple users connect to one exact node with requests you have in your personal account. As I mentioned, 40,000 requests every day is free, and if you need more, you can buy a package or unlimited. Dedicated nodes, that's node you can configure in our personal account, of course, and get your own node just for you with no limits and any protocol, any testnet, mainnet, whatever you want. And enterprise solutions, when we guarantee the huge availability, and of course fully customizable solution when you can do any of the requests, and we will provide you any add-ons like block books, any graph solutions. Maybe we can build you load balancing for several nodes and provide 10K RPS for no problem. Just a small video how to connect to our node. I will show you and explain. So this is our personal account. If you can see in the left top corner, it's a free requests, 3 of them been wasted for something. You should choose protocol and network to get your endpoint, and copy this one in the Postman in this case, or your solution which you using. Then we need to go to shared nodes, list of our shared nodes, find your protocol using your protocol, and get a sample of the requests, or you can go to the documentation, which we also provide for all our supported protocols, and put it in the body of your dApp, or in this case Postman. Then pick send, I guess, and it will be done. Yeah. Let's see. Yeah, we should change it to post, and yeah, send it and get the status of 200. It's successful and done. Amazing. For today on my side, it's almost all. As I mentioned, having a node provider is a very good thing to save your money and earn more money for your dApp. And my name is Dmitrii. That's my Telegram, my personal Telegram and email. If you have any questions right now, you can ask me. If you have more, you can scan it and reach me out any day you want and ask it personally. Thank you for listening, and have a good day. Any questions? Yeah, sure.
But just easy question. Yeah.
Let's find out.
So that would be, what would be the difference between GetBlock and like Alchemy, Tenderly, or like Llama nodes?
The best way to find out is to try it, of course, and compare. But from my side, I would say that every node provider someday will have troubles. That's that's 100% sure. And if you want to work with your dApp successfully, you'd better to have at least two node providers to back up. And yes, there is a lot of difference. And one of our advantages is the support team, which works 24 hours per 7 days, as I mentioned, and they will help you with any issue you have. You can right now just send them any request and ask why it doesn't work. They will show you the documentation, the sample of the request, how it should be working. And yeah, that's one of the most our advantages, I guess, on the market, because we are very friendly to young and small projects, and we are trying to help them developing their product. And we have a lot of solutions from the small and cheap and even free one to big and expensive. So we can help you with this whole trip from being a lonely developer in your room to big company. So yeah, that's maybe how I can answer your question. Being honest, completely honest, every node provider has some advantages, and our is the support, one of the biggest, and of course the quantity of the blockchains we support. I guess none of the providers I know, and the size and reputation they have, we are the biggest one. We have the most blockchains supported on this market. Yeah. Well, nothing. Yeah, sure.
Which blockchain, in your experience, is the hardest to run?
That's a pretty easy question because it's Solana. We have it, we support it, but yeah, it took a lot of time to get Solana working proper way, because the way when it just appeared on the market, it was pretty easy to run, but it grew so fast, so the requirement for the servers you run it became insanely high. So right now you need to have Epic AMD processor CPUs with at least 50 cores. You need to have 1 terabyte of RAM, which insanely huge amount. And yeah, that's one of the most expensive and hardest protocols to support. But yeah, we got it, and we have it on our shared and even free solutions. Yeah. Okay, I guess that's it. Thank you again, and have a great evening today. Yeah.